Three-Eye Atlas, an interstellar mystery. Welcome back to Simply About Earth, the channel where we explore the mysteries that drift through our cosmic neighborhood. Before we dive into today's story, drop a comment below and let us know where in the world you're watching from. Are you joining us from the bustling streets of Tokyo, the quiet countryside of Montana, or perhaps somewhere even more remote? We love connecting with our global community of space enthusiasts. Today's tale begins in the vast emptiness between stars, where silence reigns supreme and darkness stretches beyond imagination. The silence of space is broken not by sound, for sound cannot travel through the void, but by the weight of its own secrets. In the darkness beyond Neptune, a faint glimmer of light appeared, an object so small and dim that only the most sensitive instruments could detect it. It was the year when humanity's telescopes had grown sharp enough to pierce the veil of infinity, and yet even they hesitated before what would come to be known as the Enigma. The object would later be designated Three-Eye Atlas, the fourth confirmed interstellar wanderer to cross into our solar system. But in this first encounter, it was simply a stranger, an intruder at the gates of our cosmic sanctuary. The light was fragile, like the spark of a dying ember carried across a vast ocean of nothingness. Astronomers saw only data points scattered across their screens, coordinates, magnitudes, the cold mathematics of celestial detection. But behind those numbers lay a truth more profound than any equation could capture. The universe was not sealed, and the void was not empty. Something had come here from another star. The arrival of Three-Eye Atlas carried an emotional gravity that no calculation could measure. Humanity had already witnessed the passage of One-Eye/Oumuamua with its unnerving acceleration, and its shape too elongated to resemble any known comet. Then came Two-Eye/Borisov, a comet-like visitor carrying the unmistakable signs of interstellar chemistry. To encounter yet another intruder so soon was to feel the veil of cosmic isolation thinning, dissolving like morning mist before the harsh light of reality. No longer could Earth imagine itself merely as a lonely rock adrift in an indifferent void. The universe was beginning to speak, and each object was a syllable in a language we did not yet know how to read. For NASA scientists, the discovery was electrifying, but also deeply unsettling. Every interstellar visitor carried the potential to reshape our understanding of cosmic origins. Was this shard of matter, a fragment torn from a distant planetary system, cast adrift after some unimaginable cataclysm, or was it something more enigmatic, a messenger born of processes humanity had never witnessed? The distinction was not trivial. A rock ejected by chance was one thing, a pattern of repeated arrivals was another, a hint that the universe might be far more crowded with fragments, relics, or even devices than anyone had dared to expect. Telescopes tracked the object with precision, calculating its velocity and trajectory with painstaking care. Almost instantly, the numbers revealed an extraordinary truth. This was not a comet bound by the sun's gravity, nor a mere asteroid following the predictable paths of planets. The trajectory was hyperbolic, stretched beyond the grasp of our solar system's gravitational embrace. Its past lay among alien stars, and its future would return it to the galactic deep. It was a traveler that would not stay. The fear came quietly at first, creeping through the scientific community like shadows at dusk. If an object could slip so easily into the solar system, how many others had passed unnoticed in the centuries before telescopes existed? What if Earth had already been brushed by such fragments, or worse, struck by them? The thought gnawed at researchers in hidden ways, burrowing into their thoughts during quiet moments between observations. Catastrophes often come without warning. Here was proof that the universe could deliver visitors without notice, messengers from regions unseen, carrying with them the potential for both wonder and destruction. The question of impact was not merely theoretical. Every planetary collision recorded in the craters that pockmark the moon or scar the face of Mars was a reminder that the cosmos had teeth. But there was another fear, deeper, quieter, harder to voice in the sterile halls of scientific institutions. Some scientists wondered whether Three-Eye Atlas, like Oumuamua before it, might not be wholly natural. Its brightness fluctuated in irregular rhythms, as if sunlight reflected from surfaces not entirely random. Its course, though apparently gravitational, hinted at subtleties that raised eyebrows among those who studied orbital mechanics. NASA teams chose their words carefully in official reports, avoiding premature speculation that could ignite public panic or scientific ridicule. Still, whispers moved through the community like ripples across still water. What if these visitors were not only geological, but technological? What if interstellar space carried artifacts, probes, or relics of civilizations we had never met, and might never meet? Philosophically, the intrusion was overwhelming in its implications. To see something born in a different stellar system was to look at time itself carried across light years like a bottled message cast into a cosmic ocean. The atoms composing it had once belonged to another sun, another nursery of worlds. Perhaps they had orbited a star that had long since died in spectacular fashion. Perhaps they had witnessed a civilization rise and fall, their fragments ejected by the violence of collapsing orbits or the deliberate hand of intelligence. Every pebble in interstellar space is a history book, but the language is written in forces we are still learning to decipher. And so 3I Atlas entered human awareness as more than a point of light flickering across telescope screens. It became a symbol of intrusion, a reminder that the solar system was not a closed sanctuary, protected by distance and darkness from the chaos beyond. NASA's scientists looked upward with both excitement and unease, knowing that the universe does not deliver such mysteries without consequence. Each interstellar object was a challenge to physics, to philosophy, and to humanity's fragile sense of solitude in the cosmic dark. This was no longer the era of distant speculation about whether we were alone. The era of visitors had begun, and the arrival of 3I Atlas, faint but undeniable, marked the opening chapter of a new story, one that would blur the lines between discovery and dread, between wonder and fear. The faint light that betrayed the existence of 3I Atlas was first noticed by the Asteroid Terrestrial Impact Last Alert System, a network of telescopes whose very name carried the flavor of cosmic vigilance. Atlas had become humanity's watchtower on the night sky, scanning the heavens for sudden flares of danger, objects that might pose a threat to our fragile world. It was not built to discover interstellar mysteries, and yet, in its nightly prowl across the firmament, it captured a flicker that would grow into one of the most puzzling revelations in recent astronomy. The date of discovery would be marked in logbooks with clinical precision, a timestamp in humanity's growing catalogue of the strange. But for the astronomers at the controls, the moment was laced with the peculiar thrill of encountering something never expected, something that shouldn't have been there according to the comfortable assumptions of planetary science. At first glance, it was merely another faint moving point, one more entry among the thousands of asteroids routinely catalogued and filed away. Its speed, however, raised questions that grew more pressing with each successive measurement. With each new observation, it became clear that this object was not like the others wandering through our celestial neighborhood. Its arc across the sky betrayed a velocity that could not be accounted for by the gravitational pull of the sun alone. In the long history of astronomy, such moments have often come cloaked in confusion and wonder. When Galileo first turned his telescope skyward, he too saw things that strained the boundaries of accepted knowledge. Moons circling Jupiter, spots blemishing the supposedly perfect sun, phases on Venus that shattered ancient theories. The discovery of 3I Atlas was part of this same tradition, the sky offering evidence that the universe was stranger than the prevailing models allowed. The astronomers who first tracked the object worked late into the night, running orbital calculations that revealed its extraordinary path. A closed orbit, such as those traced by planets and asteroids, would have tied it to the sun's gravity like a celestial prisoner. But the curve of this newcomer was open, a trajectory that declared itself hyperbolic with mathematical certainty. The mathematics was unambiguous. This body was not born of our solar system. It was an outsider, flung from the gravity well of another star, its origins buried in distances almost impossible to fathom. For NASA scientists, the confirmation was electrifying. Interstellar objects were once a matter of pure theory, spoken of in lectures and modeled in equations, but never truly seen with human eyes. The appearance of Oumuamua in 2017 had cracked open the door of possibility, proving that such wanderers could and did enter our solar system. Borisov, discovered in 2019, made the phenomenon undeniable, displaying all the features of a comet, but carrying chemistry distinct from any known in local space. And now, with 3I Atlas, the door was no longer ajar, but swinging open wide. 3 intruders in less than a decade raised questions far larger than any single object could answer. The implications rippled outward like shock waves through the astronomical community, challenging assumptions that had seemed solid for generations. The circumstances of its discovery carried their own quiet irony. Atlas was meant to be a sentinel against planetary disaster, an instrument of defense against cosmic threats. Instead, it had stumbled upon something that evoked a different kind of fear, not the immediate terror of collision, but the slow-burning dread of implications. If such objects were this common, then the galaxy was alive with wandering fragments. What stories did they tell about the chaos of planetary systems, the collisions and expulsions that scattered matter across interstellar distances like seeds on a cosmic wind? And if so many wandered unseen, how many had passed unobserved, lost in the night before humanity had eyes sharp enough to catch them? In the days following detection, observatories across the globe turned their instruments toward the faint intruder. The Pan-STARRS survey, the European Southern Observatory, even amateur astronomers with high-powered backyard telescopes, all sought to add their measurements to the growing database. Collaboration intensified as data poured into shared repositories and orbital models were refined with every additional point of light captured from the darkness. The effort echoed earlier moments in the history of science when the community converged on the unexplained, united by both curiosity and caution. The very act of discovery carried a human weight that transcended mere scientific protocol. There is always a first night, a first astronomer, a first observation that pulls an object out of the silence of the unknown. The men and women who first recognized 3I Atlas were not simply plotting a rock across the heavens. They were tracing the outlines of a cosmic messenger, each pixel of data carrying the echo of a journey that had begun light years away, shaped by forces that predated Earth itself. For a brief moment, science and poetry overlapped in perfect harmony. To see 3I Atlas was to see across time, to witness the relic of a story written far from our sun's domain. Like an arrow shot from an unseen bow, it had traveled across gulfs of darkness to pierce human awareness with its silent presence. The astronomers who logged its path may have spoken in numbers and coordinates, but the undertone was reverence, tinged with fear, for in this discovery lay the realization that our solar system was not a closed book, complete and self-contained. It was merely a chapter in a greater saga, one now beginning to unfold before human eyes with each new visitor from the deep. In the days that followed its first detection, 3I Atlas became the subject of intense scrutiny. Telescopes across the globe pivoted toward its faint shimmer, and the work of refining its trajectory began in earnest, with the dedication of medieval monks illuminating manuscripts. Astronomers live and breathe by orbital mechanics. With each new data point, the path of an object can be sharpened, its story written into equations with increasing precision. For 3I Atlas, those equations told a tale that was at once exhilarating and deeply unsettling. Its orbit was hyperbolic, a curve that would never close, never return to familiar skies. This was not a comet tied to the sun's embrace, nor an asteroid drawn by the familiar gravity of our star. Its journey was one way, into the solar system, and then out again, a fleeting visitor from the dark between stars. To trace the path of such an intruder is to peel back layers of cosmic history like an archaeologist excavating ancient ruins. Orbital mechanics does not lie, cannot be deceived or misled. The arc of motion carries within it the fingerprints of origin, the mathematical DNA of its birthplace. Calculations revealed that 3I Atlas had entered the solar system from a direction just offset from the constellation Lyra. Its velocity, clocked at tens of kilometers per second, was far greater than anything a solar orbit could produce. It had been accelerated elsewhere, flung across interstellar space by the gravitational violence of a system not our own. For scientists at NASA's Jet Propulsion Laboratory, the implications were profound and far-reaching. This was matter that had been forged in another stellar cradle, orbiting another star, perhaps once part of another planet or moon. As the data accumulated like puzzle pieces, astronomers turned to precedent for guidance. Oumuamua, the first interstellar object detected, had also traced a hyperbolic path, slipping past Earth with disturbing speed. Borisov, arriving 2 years later, had displayed the classic features of a comet but carried within it alien isotopic ratios that spoke of formation under foreign skies. Now 3I Atlas fit the same pattern, its trajectory confirming once again that the galaxy was not still and static, but dynamic and restless, scattering fragments of its architecture across gulfs of space like a cosmic storm. The repetition of this theme was not comforting to those who studied the data. 3 times in a few short years, the cosmos had delivered messengers, and each had carried its own unsettling details, its own resistance to easy classification. NASA scientists often describe orbital calculations as a dialogue with the universe, each adjustment of numbers narrowing the uncertainty, bringing clarity to chaos. But here the dialogue was laced with suspicion and unease. The hyperbolic orbit was steep, more open than any local asteroid could sustain. It traced a course that implied vast distances traveled, eons of wandering through interstellar voids where stars appear as mere points of light. Yet the object retained a brightness inconsistent with a purely ancient fragment. It gleamed as though it were fresher, more intact than one might expect of matter weathered by cosmic rays for millions of years. To reconstruct its past, astrophysicists asked fundamental questions that reached to the heart of planetary formation. From what kind of system could it have come? A violent scattering event in a young planetary nursery could have ejected it, forming gas giants flinging smaller bodies outward in gravitational chaos, or perhaps a catastrophic stellar death, a supernova or gravitational upheaval, had shattered worlds and cast debris into space like cosmic shrapnel. Each model hinted at chaos far removed from our Sun's relative stability. If 3I Atlas was born of such violence, then it was a survivor, a relic carrying scars from a forgotten drama written in another sky, played out before human civilization even existed. The trajectory also raised practical concerns that kept mission planners awake at night. Interstellar visitors pass through quickly, and opportunities to observe them are fleeting, precious beyond measure. By the time orbital solutions confirmed its hyperbolic nature, 3I Atlas was already receding toward the outer solar system. Instruments had precious little time to gather light curves, spectral fingerprints, and velocity refinements before the object would fade beyond reach, disappearing into the cosmic background like a ghost returning to the shadows. The urgency was palpable in observatories around the world. Every night of observation was treated as if it might be the last chance to unlock the object's secrets. Astronomers worked in shifts, maximizing telescope time, pushing instruments to their limits in a race against the inevitable. There was also an emotional weight carried by those who traced its orbit, a sense of profound responsibility mixed with humbling awareness. To follow its curve backward was to imagine the unimaginable distances it had crossed, the lonely eons spent drifting through the void between stars. Somewhere in the depths of Lyra's direction lay its true birthplace, though the exact source would remain unknowable, hidden by the chaos of galactic tides and the gentle nudges of passing stars over cosmic time. And yet, to plot its path was to confront the reality that our solar system was not isolated, not protected by distance from the wanderings of the galaxy. Space is porous, and the walls of our star's domain are more like open gates than fortress barriers. Visitors can arrive unbidden, and they can carry with them mysteries older than Earth itself. Tracing the path of 3I Atlas, NASA scientists were struck by the tension between certainty and ignorance that defines so much of astronomy. The mathematics was exact, the orbit hyperbolic, the speed undeniable, the origin clearly interstellar. And yet the deeper story, the why of its journey, the meaning of its arrival, remained veiled in cosmic uncertainty. The trajectory answered one question only to open a dozen others, each pointing toward vast, unsettling possibilities that stretched the imagination. Thus, the act of tracing its path became more than a technical exercise in celestial mechanics. It was an act of recognition, a moment when humanity looked up and realized that the boundaries of our familiar sky had been breached again. The universe was not quiet, not sleeping peacefully in the cosmic night. It was sending emissaries, and each one arrived with whispers that unsettled the certainties of physics and philosophy alike. Comparisons are the natural language of science, the way researchers make sense of the unknown by relating it to the known. When faced with the strangeness of 3I Atlas, astronomers inevitably turn their thoughts backward to the two other interstellar wanderers that had already disturbed the tranquility of our solar system. These predecessors, Oumuamua and Borisov, had written the first chapters of an entirely new category of astronomy. By setting 3I Atlas beside them, scientists sought context, pattern, and perhaps a glimpse of deeper meaning hidden in the sequence of arrivals. Oumuamua, discovered in 2017, was the herald of this new age. Its very name, drawn from Hawaiian, meant a messenger from afar arriving first. A designation that proved remarkably apparent. Unlike any comet or asteroid ever seen, it carried an elongated shape, cigar-like or perhaps pancake-flat, depending on the interpretation of its strange light curves. Most haunting of all was its peculiar acceleration as it departed our vicinity, a subtle push that could not be explained by gravity alone. Normally, comets gain such acceleration through outgassing jets of sublimating ice, acting like natural thrusters. Yet Oumuamua betrayed no such activity, no coma, no tail, no cloud of dust or water vapor to explain its motion. The debate still smolders in scientific journals and conference halls. Was it a shard of exotic hydrogen ice, eroded invisibly by solar radiation? A fractal fragment of carbon-rich dust with unusual properties? Or, as some daring voices suggested, something artificial, a probe designed by intelligence unknown? Then came Borisov in 2019, designated 2I/Borisov. Unlike Oumuamua, it appeared immediately familiar, a classic comet haloed by a luminous coma and trailing a magnificent tail that stretched across the sky like a cosmic banner. But Borisov's chemistry marked it as unmistakably foreign. Its gases bore the fingerprint of formation under conditions unlike those of our solar system, enriched with carbon monoxide in ways that startled planetary scientists. It was, in essence, proof that the processes that shaped comets here also unfolded around distant suns, though with striking differences that spoke of alien environments. Borisov reassured and unsettled in equal measure. It was comfortingly cometary, yet undeniably alien in its chemical signature. With these two cases as precedent, the arrival of 3I Atlas pressed urgently on the question of whether patterns existed in these visitations. Was Oumuamua a bizarre anomaly, Borisov a more conventional representative, and Watcher something in between? Or did their rapid succession suggest that interstellar debris was far more abundant than ever suspected? If 3 such objects could be discovered within a span of mere years, then perhaps the galaxy teemed with wanderers, fragments from the formation and destruction of countless planetary systems, drifting like cosmic tumbleweeds through the void. NASA's community of researchers framed 3I Atlas within this evolving narrative. It shared with Oumuamua a certain faintness, an ambiguity of shape that frustrated attempts at classification. It shared with Borisov the role of corroboration, proving that interstellar visitors were not rare once-in-a-century anomalies, but events unfolding within the lifetimes of living scientists. The contrast between the three painted a portrait of diversity that was both fascinating and troubling. No single class of interstellar object emerged from the data, but rather a spectrum of forms, each carrying distinct signatures of origin and evolution. The unease lay in what this implied about the nature of space itself. If interstellar debris could take so many shapes and forms, then the possibilities extended beyond the purely natural. Oumuamua's unexplained acceleration continued to cast a long shadow over discussions, and the discovery of 3I Atlas rekindled those uncomfortable questions. Were these truly random fragments ejected by natural processes, or could some of them be instruments, scouts, or relics of long-vanished civilizations? The speculation was uncomfortable for scientists trained in careful methodology, but it refused to vanish entirely. Harvard astronomer Avi Loeb's controversial suggestion that Oumuamua might have been technological still echoed in debates, and 3I Atlas arrived like a ghost of that argument, reminding researchers that dismissing the extraordinary too quickly could be as dangerous as embracing it too readily. Beyond speculation, the comparisons also carried emotional weight that transcended pure science. Humanity had lived for millennia with the assumption that the night sky was eternal and still, its lights unmoving, save for the wandering planets and occasional comet. The revelation that interstellar visitors passed through our neighborhood shattered that ancient illusion. The solar system was not a closed sanctuary, protected by vast distances from the chaos beyond. It was an intersection on a galactic highway, with traffic moving unseen through the darkness for eons before human eyes grew sharp enough to notice. Oumuamua, Borisov, and Watcher were simply the first that humanity had managed to detect and study. Each discovery had altered perception in subtle but profound ways. Oumuamua instilled awe laced with suspicion, the first crack in our cosmic isolation. Borisov provided proof that alien chemistry could be studied directly without leaving our solar system, bringing the laboratory of space to Earth's doorstep. And 3I Atlas arrived carrying both threads, the suspicion of strangeness and the assurance of abundance. The comparisons were not merely academic exercises in classification. They underscored that humanity stood at the threshold of a new discipline, interstellar archaeology, the study of relics flung across the galaxy by forces both natural and perhaps otherwise. Yet this realization was not entirely comforting. If visitors were this common, then our solar system was far less isolated than once imagined. The boundaries of our cosmic neighborhood were porous, and every arrival carried not only scientific promise, but also existential unease. The comparison with its predecessors served as a reminder that the universe was in constant motion, restless and dynamic. Earth was but a fragile outpost in a sea filled with messengers whose stories we had only begun to decipher, each one carrying fragments of history from stellar systems we might never visit, crafted by processes we might never fully understand. From the beginning, 3I Atlas carried with it a riddle that unsettled the tidy frameworks of celestial mechanics. Its motion was not perfectly obedient to the dictates of gravity, not entirely predictable according to the elegant equations that had governed astronomical prediction for centuries. Astronomers expect interstellar visitors to trace smooth arcs shaped by the pull of the sun, just as comets and asteroids do in their eternal dance around our star. Yet, when the data for 3I Atlas was gathered and refined with painstaking care, subtle deviations emerged, accelerations too faint to be dismissed as instrumental noise, yet too consistent to ignore. These shifts echoed in a haunting way the behavior of Oumuamua, which had seemed to shrug off the sun's gravitational grip, as though some hidden hand were propelling it outward into the cosmic deep. At first, scientists searched desperately for natural explanations. Comets often alter their speeds when heated by solar radiation, jets of sublimating ice firing like miniature thrusters in the vacuum of space. But telescopes scanning 3I Atlas failed to reveal the familiar signatures of such activity. No coma blossomed around it like a flower of light. No luminous tail marked its wake across the star field. The absence was damning, an object behaving like an active comet, but refusing to display the visible characteristics of one. The rules of celestial categories blurred, and uncertainty spread through the calculations like ripples across still water. The strangeness deepened when brightness curves were studied in detail. As sunlight struck its surface, the reflections shifted in patterns that resisted easy interpretation. Instead of the steady rhythm one might expect from a roughly spherical body rotating predictably, the object flickered in uneven pulses, as though it were tumbling around an irregular or highly elongated form. Some models suggested a fractured shard, jagged and tumbling unpredictably through space like a broken piece of cosmic pottery. Others imagined a pancake-thin sliver, broad enough to flash brilliantly when aligned just so with Earth's viewpoint, then vanish into shadow as it rotated away. Each scenario carried with it the unsettling possibility that the shape itself was driving its odd motion, catching and redirecting solar photons in ways unfamiliar to planetary science. The idea of non-gravitational acceleration has always been a point of discomfort in astronomy because it opens doors to questions that feel uncomfortably close to speculation. Could radiation pressure alone, the gentle but persistent push of sunlight on a reflective surface, account for the deviations observed in 3I Atlas's trajectory? Calculations suggested it was possible, if the object were far lighter than expected, perhaps a structure no thicker than a sail spread wide to catch the solar wind. But such a conclusion demanded leaps of imagination that made conservative astronomers uncomfortable. Nature rarely produces such geometries without external intervention, while technology could and had, on Earth. The line between natural shard and artificial craft blurred like watercolors in rain, leaving NASA scientists with the uncomfortable burden of considering scenarios that straddled the edge between rigorous science and science fiction. At the same time, the motion of 3I Atlas challenged another fundamental assumption. Objects ejected from planetary systems are expected to wander aimlessly through space, their velocities shaped by chaotic scattering events and the gentle tides of stellar gravity over millions of years. But 3I Atlas seemed to follow a course that was unnervingly precise, sliding through our solar system with a path that intersected Earth's neighborhood at a time that seemed almost too convenient to be coincidental. The statistical odds of such alignments gnawed at the minds of orbital modelers. Randomness was always the default assumption in astronomy, the comfortable baseline against which all observations were measured. Yet repeated improbabilities began to suggest something else, design perhaps, or at the very least processes that science did not yet understand. What troubled NASA researchers most was not the magnitude of the anomalies. They were small, subtle, requiring careful analysis to detect, but their persistence. The data never yielded to neat corrections or simple explanations. Each effort to reconcile the acceleration with familiar physics strained the models, stretching assumptions until they threatened to snap under the weight of contradiction. The object's refusal to behave in ordinary ways became its defining characteristic, a cosmic enigma wrapped in mathematical uncertainty. And just as Oumua's strangeness had left a lingering suspicion in the astronomical community, 3I Atlas reignited the same unease with even greater intensity. Perhaps the universe was trying to tell a story far more complicated than the one humanity was prepared to hear. Within the halls of the Jet Propulsion Laboratory, discussions slipped into hushed tones during coffee breaks and late-night planning sessions. No one wanted to declare the object unnatural, not without irrefutable proof that could withstand the scrutiny of peer review, but the comparison to its predecessors was inescapable and troubling. A trio of interstellar wanderers in less than a decade, two of them defying gravitational orthodoxy in subtle but measurable ways, painted a picture too sharp and consistent to dismiss as mere coincidence. Some feared what it implied about cosmic abundance, that space was filled with objects whose behavior defied easy categorization. Others feared what it might mean about intention, about the possibility that intelligence, somewhere and somewhen, had left its mark on the galaxy in ways humanity was only beginning to recognize. For the public, such subtleties remained hidden in the technical language of orbital reports and observational bulletins. But within the scientific community, the whisper grew like a slowly spreading fire. 3i Atlas was behaving in ways that mocked traditional classification, a celestial chameleon that refused to settle into familiar categories. A comet that was not quite a comet, an asteroid that would not remain still under gravity's supposedly inviolable law, a messenger that carried its secrets lightly, but with deliberate persistence that suggested purpose behind its wandering. And so the enigma of its motion became more than a matter of celestial mechanics or observational astronomy. It became a mirror reflecting back at humanity the fragility of its assumptions about the cosmos and its place within it. The solar system, once imagined as orderly and predictable as clockwork, was proving to be porous and strange, a realm where visitors arrived unbidden from the deep, carrying with them behavior that suggested rules not yet written in any textbook. The scientists who watched 3i Atlas glide across the night sky felt both awe and unease, knowing that the mystery of its motion was only the beginning of deeper shocks yet to come. Light is the oldest messenger in the universe, traveling across impossible distances to bring news of distant realms. Every photon carries a story, whispering across the void with perfect fidelity, bearing witness to events that occurred long before human eyes existed to see them. When astronomers studied 3i Atlas, it was this light, reflected sunlight captured by telescopes and translated into data, that became the only window into its true nature. Yet the light deceived more than it revealed, painting a portrait of contradiction that shifted and changed with each new observation. The first measurement suggested an ordinary faintness, a magnitude consistent with a small object passing quickly through our solar system like countless others before it. But as nights passed and the data accumulated, the brightness fluctuated in ways that unsettled even experienced observers. Comets tend to brighten predictably as they near the sun, their surfaces igniting into glowing halos of sublimated ice and dust. Asteroids reflect sunlight with relative steadiness, their light curves shaped by rotation and surface features, but following comprehensible patterns. 3i Atlas belonged to neither world, existing in some liminal space between categories. Its reflections pulsed irregularly, sometimes brightening sharply as though a mirror had suddenly caught the sun, sometimes dimming into near invisibility, as though the object had turned its back on Earth entirely. The rhythm defied simple explanation, refusing to settle into the comfortable patterns that astronomers had learned to expect from natural bodies. Models were constructed with increasing desperation to explain the erratic behavior. Perhaps it was tumbling chaotically, an irregular shard spinning through space like a broken piece of cosmic debris. Perhaps its surface was unusually smooth in places and rough in others, catching sunlight in sudden flashes like a disco ball tilted toward Earth. Some even proposed that the object was fragmentary in nature, a loose cluster of smaller bodies drifting together in gravitational embrace, their collective light waxing and waning as they rotated in loose formation through the void. None of these explanations satisfied completely, for each demanded assumptions about structure or material composition that were far removed from what nature usually provides, at least in the familiar confines of our solar system. The spectra deepened the confusion rather than resolving it. When astronomers broke the light into its component colors, searching for the chemical fingerprints that would reveal composition, they expected to find signatures of common ices or familiar minerals, water vapor, carbon compounds, silicates, the building blocks of worlds and wanderers alike. Instead, the readings were sparse and muted, resistant to clear interpretation. It was as if the surface was somehow cloaked, either by material unfamiliar to terrestrial experience or by a geometry that denied easy analysis. In the language of light, 3i Atlas spoke in whispers, revealing too little to trust, yet too much to ignore entirely. This optical deception echoed the earlier riddle of Umumor, whose faint reflections had baffled even the Hubble Space Telescope's sophisticated instruments. That object had seemed at times metallic, at times dusty, its colors shifting with each attempt to pin down its true nature. 3I Atlas continued this troubling tradition of ambiguity, and the comparison weighed heavily on those at NASA, charged with interpreting the data. For in astronomy, light is supposed to be law, the fundamental currency of truth, that travels unaltered across space and time. Yet here that law seemed broken, or at least bent in ways that challenged basic assumptions about how matter interacts with radiation. There were moments when the brightness suggested an unnatural regularity, as though flat panels or precisely engineered surfaces had caught the sun in deliberate fashion. Some whispered of solar sails, thin structures designed to harness radiation pressure for propulsion across interstellar distances. Others counseled restraint, reminding colleagues that fractured shards of rock can, under certain conditions, reflect light in ways that mimic intentional design. Nature is capable of producing geometries that appear artificial to human eyes, particularly when viewed from a distance through the filter of limited data. Still, the suspicion lingered like smoke in a closed room. The deception of light might not be accidental, might not be merely the result of natural processes operating under unusual conditions. The public, reading popular reports and press releases, often imagined telescopes producing crisp images, detailed photographs of distant objects like pictures in a travel magazine. In truth, 3I Atlas was nothing more than shifting points of light on detector screens, numbers rendered from photons collected over long exposures and translated into brightness measurements. The deception was not in the instruments, but potentially in the object itself, refusing to offer the clarity that numbers usually provide to patient observers. For scientists accustomed to extracting certainty from faint signals, to building reliable knowledge from statistical analysis of photon counts, the experience was deeply unsettling. The fear beneath the science was philosophical in nature, striking at fundamental assumptions about the relationship between observation and truth. Light is supposed to be honest, incapable of deliberate deception. It carries the past into the present with mathematical precision, encoding information about temperature, composition, motion, and structure in wavelengths and intensities that can be decoded by those who know the language. If an object actively hides its identity even when bathed in light, then the universe is not merely mysterious in the way that science expects mystery. It becomes actively withholding, deliberately obscure in ways that suggest intention behind the concealment. And so, in observing 3I Atlas, astronomers were forced to admit a possibility that challenged their most basic assumptions. Some stories might not be meant to be read easily. Some visitors might arrive cloaked in riddles, their surfaces designed by nature or by something else to mislead rather than inform. In the halls of NASA, debates stretched into the early hours of morning as scientists grappled with the implications. Was the deceptive brightness curve evidence of a natural shard tumbling unpredictably through space, shaped by eons of cosmic weathering into an irregular form that reflected light in strange ways? Or was it something crafted, something intentional in its deception, designed to appear natural while concealing its true nature from casual observation? Each possibility carried equal weight in the absence of definitive proof, and each carried implications that stretched far beyond the realm of astronomy into questions of philosophy, purpose, and humanity's place in a universe that might be far stranger than anyone had dared to imagine. Thus, the light of 3I Atlas became more than mere illumination reflecting off a distant surface. It became a veil, shimmering with half-truths and contradictions, daring observers to look closer, to question harder, and to accept that even the oldest messenger in the universe, light itself, could become an instrument of concealment rather than revelation. As telescopes continued to track 3I Atlas across the star field, the central question pressed harder against the boundaries of known science. Where had it come from? To know its origin was to anchor its meaning. to place it within a context that might make sense of its strange behavior and mysterious properties. Yet, every attempt to answer this fundamental question only expanded the horizon of doubt, opening new vistas of uncertainty that stretched the imagination to its limits. Trajectory analysis suggested that the object had entered our solar system from a direction near the constellation Lyra, but that offered only a compass point in the cosmic dark, not a true birthplace. Over interstellar distances measured in light years, even the cleanest orbital path is blurred by countless encounters with invisible forces. Stellar winds, galactic tides, the faint but persistent tugs of passing stars over millions of years, all conspire to erase the trail of origin like footprints in shifting sand. By the time an object like 3I Atlas reaches our domain, its trajectory is ancient history, its true source veiled in layers of gravitational chaos that no amount of calculation can fully unravel. Some scientists argued it was simply the product of violent scattering events that occur naturally in young planetary systems. During their chaotic youth, stellar nurseries are scenes of cosmic upheaval, giant worlds forming and migrating, their immense gravitational influence playing games with smaller bodies. In this cosmic billiards, countless fragments are inevitably flung outward, ejected from their birth systems to wander the galaxy as interstellar nomads. Most drift endlessly through the void, never to be seen again, invisible particles in the cosmic wind. If 3I Atlas were such a fragment, then it was the echo of ancient birth pangs, a shard from a planetary nursery now separated from us by unimaginable distances and eons of time. Yet this straightforward explanation did not entirely settle the unease that surrounded the object's discovery. Its unusual structure and anomalous behavior hinted at something more complex than simple gravitational ejection, something that defied the comfortable assumptions of planetary formation theory. Others considered the possibility of stellar catastrophe as the driving force behind its journey. Perhaps an entire world had been shattered in the death throes of its parent star, debris cast across light years, like cosmic shrapnel in the aftermath of supernova violence. Such explosions are known to seed the galaxy with heavy elements, the building blocks of planets and life scattered across vast distances. Why not also planetary fragments themselves, the orphaned bones of destroyed worlds wandering through time as relics of cosmic violence? In this model, 3I Atlas might be the remnant of a place that no longer existed, a piece of geography from a world whose star had died in spectacular fashion long before Earth formed in the disk of our own solar nebula. Such an explanation carried a somber poetry that appealed to astronomers with philosophical inclinations. To look at the object was to gaze upon the remains of a lost world, to hold in telescopic view a fragment of planetary history from a stellar system that had been erased from the galaxy's active inventory. But speculation did not stop at natural violence and gravitational chaos. As the anomalies mounted and the explanations grew more strained, some researchers began to whisper of intentionality, of purpose behind the object's presence in our neighborhood. If 3I Atlas's behavior resembled that of a solar sail catching starlight for propulsion, could it have been designed specifically to travel between stellar systems? Radiation pressure is weak but eternal, a force that could, with sufficient patience and proper engineering, carry a thin enough structure across the galaxy using nothing more than starlight as fuel. To entertain such a thought was to step into territory that made conservative scientists uncomfortable, for it meant considering the possibility that 3I Atlas was not merely from somewhere else, but had been deliberately sent from that distant origin. NASA's teams avoided public speculation about artificial origins, maintaining the careful neutrality that befits scientific institutions. But in private discussions, the debate grew more pointed as the evidence accumulated, each new anomaly adding weight to scenarios that had once seemed purely fantastical. The rapid succession of 3 interstellar visitors in less than a decade raised uncomfortable questions about probability and coincidence. Was this merely the result of improved detection capabilities, humanity finally developing eyes sharp enough to see what had always been there? Or did it reveal a density of interstellar objects that had been underestimated by orders of magnitude, suggesting that the galaxy was littered with wandering fragments far beyond what anyone had imagined? If space was truly filled with such objects, then 3I Atlas was but one messenger in an endless stream, a single voice in a cosmic chorus that humanity was only beginning to hear. Yet, if patterns of motion and behavior hinted at something more deliberate than random wandering, if the sequence of arrivals suggested coordination rather than chance, then the implications stretched into realms that science was not prepared to explore publicly. Even the question of age hung over every discussion like a shadow. How long had this traveler been wandering between the stars? Had it drifted for millions of years before brushing Earth's neighborhood, a patient voyager older than complex life on our planet? Or had it been set on its path more recently, perhaps in the lifetime of civilizations that might still exist somewhere among the distant stars, watching and waiting for reports from their wandering scouts? Each possibility carried its own weight of implication. If ancient, then 3I Atlas was a fossil of cosmic history, a relic from an era when the galaxy was younger and perhaps more violent. If recent, it might imply connections to forces or intelligences that remained active, still capable of launching objects on interstellar trajectories for purposes unknown. Philosophically, the origin debate cut to the heart of human self-perception in the cosmic order. If 3I Atlas was merely a fragment of stone or ice, its arrival was still testimony to the galaxy's restless dynamics, reminding humanity that we live in an open system where nothing is truly isolated or protected. But if it bore even the faintest trace of design, if it carried within its structure or behavior the signature of intentional creation, then our solar system was no longer untouched by outside influence. We would have been visited, observed, perhaps even catalogued by intelligences whose motives and capabilities remained utterly alien. In the end, scientists could not fix the object's birthplace on any star chart with confidence. The data bent under too many uncertainties, too many gravitational perturbations accumulated across too many epochs of galactic rotation. And yet the mystery of origin did not weaken the sense of unease that surrounded 3I Atlas. If anything, it sharpened that fear into something more focused and immediate. For what cannot be traced, cannot be fully explained, and what cannot be explained demands caution from those who encounter it. Thus, 3I Atlas remained an exile in the truest sense, a wanderer without a known home, carrying in its silence the unsettling possibility that the galaxy was far more alive with fragments, relics, and perhaps intentions than humanity had ever dared to believe. The question of where it came from remained open like an unhealed wound, but the implications of its journey had already begun to spread unease through the halls of every major observatory on Earth. Velocity is not merely a measure of speed in the lexicon of astronomy, it is biography written in numbers, the life story of an object encoded in its motion through space. How fast something moves tells the tale of how it was born, what forces shaped its journey, and how far it has traveled from its point of origin. For 3I Atlas, the numbers were disturbing from the very first calculations, revealing details that challenged comfortable assumptions about the nature of interstellar space. Its inbound velocity was measured at over 30 kilometers per second relative to our Sun, already far beyond the reach of any orbit that could be sustained by solar gravity alone. But even more troubling was its excess speed, the surplus motion that could not be explained by gravitational assists from planets or ejection mechanisms within our own stellar system. It carried with it the unmistakable signature of an origin measured in light years, the kinetic fingerprint of forces that had operated beyond the boundary of our cosmic neighborhood. The question gnawed at researchers with increasing intensity. What could have launched an object with such tremendous velocity across the interstellar void? The simplest explanation pointed toward planetary scattering events that occur naturally during the formation of stellar systems. In the youth of any star, newborn gas giants often migrate inward or outward, their immense gravitational influence kicking smaller bodies in all directions like cosmic billiard balls. Millions of objects are cast into the void this way, doomed to wander through space as gravitational exiles from their birth systems. Most drift silently through the galaxy, invisible and undetectable until they happen to pass close enough to another star for observation. But when theoretical models were tested against the observed velocity of 3I ATLS, a disturbing result emerged. Its speed was too high, significantly beyond what even the most violent planetary ejection events typically produce. Even chaotic encounters with migrating giants tend to impart somewhat lower velocities to ejected bodies, the result of energy conservation and the finite gravitational resources available during scattering events. 3I Atlas seemed unnaturally quick, as though it had been thrust outward by forces beyond the usual gravitational dance of planetary formation. Some researchers suggested stellar catastrophe as a more plausible explanation, a dying star collapsing into a white dwarf, or the even more violent death spiral that creates neutron stars, could shatter orbiting planets and fling their fragments outward at tremendous speeds. Such events can impart velocities far exceeding normal planetary interactions, enough to easily explain an object moving as fast as 3I Atlas. If this scenario were correct, then the visitor was not just a shard of rock and ice, but the survivor of a star's death, a fragment that had carried its tremendous velocity across light years as an inertial memory of cosmic destruction. To look at its speed was to glimpse the echo of a stellar funeral, the mathematical ghost of violence that had occurred long before our solar system finished forming from its primordial disk of gas and dust. Others proposed more exotic origins that pushed the boundaries of conventional astrophysics. Could 3I Atlas have been accelerated by interactions with dark matter, slipping through regions where unseen mass concentrated in ways that imparted unusual momentum? Or could it have been driven by radiation pressure over vast periods of time, a thin shard gradually pushed to impossible speeds by the steady hand of starlight accumulated across millions of years of interstellar travel? Such theories blurred the boundary between natural processes and artificial design in uncomfortable ways. While radiation pressure could indeed propel debris over cosmic timescales, it could also propel deliberately constructed sails designed to harness stellar energy for interstellar travel. The possibility hung unspoken but present in every discussion. Velocity itself might be a clue not to random ejection, but to intentional design. The direction of travel compounded the unease felt by orbital analysts. When 3I Atlas's trajectory was traced backward through time, it did not intersect any known stellar nursery or obvious source of violent activity. It seemed to emerge from empty space, following a path too clean and direct for something that had drifted aimlessly through the chaotic gravitational environment of the galaxy. Random debris should bear the scars of countless gravitational deflections, accumulated course changes from encounters with stars, molecular clouds, and the invisible dark matter that threads through galactic space. Yet the motion of 3I Atlas was unnervingly precise, as though it had been set deliberately on its trajectory with minimal deviation over cosmic time. Even small gravitational perturbations, amplified across light years and millions of years, should have left clear traces of chaos in its orbital elements. Instead, the precision was almost surgical, too clean for comfort. For NASA scientists trained to expect randomness as the natural state of the universe, the speed and direction of 3I Atlas raised not only technical puzzles, but also existential questions about the nature of interstellar space. If the galaxy was truly alive with debris moving at such velocities, then Earth's position within it was more precarious than anyone had calculated. Collisions with interstellar wanderers might be rare events, but they were not impossible, and the energy released by an impact at these speeds would dwarf any catastrophe in recorded human history. Yet, beyond this practical concern lay a subtler dread, the possibility that velocity itself might be a signal rather than merely a consequence of natural forces. Objects do not achieve such speeds by accident, particularly not while maintaining such precise trajectories over cosmic distances. If 3I Atlas had been launched deliberately, whether by the physics of stellar death or by the intention of unknown engineers, then its tremendous speed was more than a kinematic measurement. It was a message, and the message was written in the universal language of motion itself. Philosophically, the enigma of velocity carried an even deeper weight that resonated through every aspect of human understanding. For centuries, our species had measured its place in the universe through motion, planets circling the sun, stars drifting across the sky in their stately procession through cosmic time. Speed had always been a measure of relative safety, a way to calculate the future and predict the paths of celestial objects with confidence born of mathematical certainty. But here was an object that defied the expected patterns, an interloper carrying with it the kinetic energy of unknown origins and unguessable purpose. In its relentless motion, scientists glimpsed both the violence of the cosmos and the possibility of intention, the dual nature of a universe that might be simultaneously chaotic and designed. Thus, the speed of 3I Atlas was not merely a number to be filed in orbital databases and research papers. It was a wound in the map of cosmic understanding, a reminder that velocity is not only a physical quantity, but also a story. And this particular story was one that humanity had not yet learned how to read, much less how to answer, if it proved to be a question directed at us from the darkness between the stars. As the data on 3I Atlas accumulated like pieces of a cosmic puzzle, astronomers began to focus intensively on its shape and surface characteristics, the physical features most elusive yet most revealing of an object's true nature and history. Every interstellar wanderer carries with it a geometry that hints at its past, the scars of collisions, the smoothing effects of eons spent in the cosmic wind, and perhaps in the darker corners of speculation, the intentional design of unknown architects. For 3I Atlas, the optical signals told a story that was neither clear nor particularly comforting to those who sought simple explanations. The light curves, those subtle oscillations in brightness as the object rotated through space, suggested something highly irregular in shape, unlike the roughly spherical asteroids that populate our solar system's main belt, or the smoother ellipsoidal nuclei typical of comets. 3I Atlas appeared dramatically asymmetric, tumbling through space in ways that defied easy modeling. Some computational reconstructions rendered it as an elongated shard, a cosmic splinter perhaps 10 times longer than it was wide, spinning end over end like a thrown javelin. Others imagined a flattened form, thin as a dinner plate but stretched across hundreds of meters, flickering like a cosmic mirror as it caught and lost the sun's rays with each rotation. Still other models considered the possibility of a loose aggregate, a cluster of fragments held together by weak gravitational attraction, reflecting light unevenly as individual pieces drifted in and out of alignment. None of these portraits felt entirely convincing, and yet all carried implications that reached beyond mere geometric curiosity into realms of profound unease. Comparisons with Oumuamua deepened the mystery rather than resolving it. That earlier interstellar visitor had also defied easy classification, its shape elongated far beyond any asteroid seen in our local neighborhood, its surface properties shifting with observation angle in ways that frustrated the most sophisticated analysis. 3I Atlas seemed to echo those troubling features, but with differences sharp enough to prevent comfortable categorization, as simply another example of the same phenomenon. Was it mere coincidence that both confirmed interstellar visitors displayed such improbable geometries, or was there a pattern emerging, one that hinted at processes operating beyond our solar system's boundaries, shaping matter in ways that local experience had not prepared us to recognize? Surface composition analysis added another layer of complexity to an already confusing picture. The object's reflectivity was notably low, darker than most asteroids, suggesting either carbon-rich material typical of the outer solar system or extensive weathering by cosmic radiation during its long journey between stars. Yet, the albedo was not uniformly low. Certain observation angles revealed brighter flashes, as though portions of the surface were significantly smoother or more metallic than others. This patchwork reflectivity pattern resisted straightforward interpretation. Spectroscopic analysis, the breaking down of reflected light into component wavelengths to reveal chemical composition, refused to settle the matter definitively. Some readings hinted at water ice or organic compounds, others suggested silicate rock similar to terrestrial materials. But the signals were consistently muted and ambiguous, as though the surface was somehow cloaked in material unfamiliar to astronomical experience. A coating of organic tholins, complex carbon compounds produced by radiation processing over cosmic timescales, might explain the overall darkness, but not the intermittent flashes of higher reflectivity that suggested harder, more pristine surfaces beneath. For NASA scientists accustomed to clear spectroscopic signatures that reveal composition with confidence, the ambiguity was maddening. Every measurement seemed designed to frustrate rather than inform, raising more questions than it answered. The combination of unusual shape and puzzling surface properties was particularly troubling because it echoed concerns that had never been fully resolved about Oumuamua. Nature certainly produces irregular fragments through collisional processes, but not often ones that so closely mimic the characteristics one might expect from artificial structures. A thin shard could indeed be natural, torn from a larger body during a catastrophic impact in some distant stellar system, but it could also resemble the remnant of a solar sail, a structure designed to catch starlight for propulsion across interstellar distances. A metallic glint could be the natural result of mineral composition, but it could also be the reflection from engineered surfaces whose purpose remained hidden beneath layers of cosmic dust and radiation damage. In the margins of scientific papers and the informal discussions that occur after formal presentations, the question persisted like an itch that could not be scratched. Was 3I Atlas merely a geological relic, the random product of cosmic violence played out in another stellar system millions of years ago? Or was it something more, a relic of intention bearing within its structure the signature of design by intelligences whose capabilities and motivations remained utterly alien to human experience? Even if entirely natural in origin, the object's shape raised troubling possibilities about the processes that had created it. If it were a collision fragment, it might represent the remains of a catastrophic impact that had shattered an entire world, reducing a planet to debris scattered across interstellar space. If it were the product of tidal disruption, it could be the remnant of a moon or small planet that had wandered too close to a massive star, stretched and torn by gravitational forces beyond imagination. Each scenario spoke of violence on scales that dwarfed anything in our solar system's recent history, cosmic catastrophes that could erase worlds and scatter their remains like cosmic confetti across the galaxy. To look at 3I Atlas was potentially to gaze upon a survivor, a fragment that had somehow endured forces capable of destroying entire civilizations and their worlds. Philosophically, the surface and shape of the object became a kind of Rorschach test for human interpretation. To some observers, it represented clear proof of the universe's capacity for random violence, evidence of a cosmos where chance and chaos sculpt matter without regard for meaning or purpose. To others, it whispered of design, a geometry and surface composition too carefully structured to be entirely accidental, hinting at engineering principles and materials science developed under alien skies. Between these extremes lay a vast territory of uncertainty, a space where the object could be simultaneously natural and artificial, familiar and alien, comprehensible and utterly mysterious. In scientific meetings where 3I Atlas's characteristics were debated, slides displaying light curves and spectral analyses became battlegrounds for competing interpretations. Arguments raged over whether the irregularities fell within the range of natural expectation, yet beneath the technical discussions lay a quieter truth that few were willing to voice directly. 3I Atlas refused to reveal itself completely, its shape and surface characteristics simultaneously familiar enough to seem plausible and strange enough to inspire doubt. It existed in a state of perpetual ambiguity, an object that seemed designed by the universe itself to frustrate human attempts at definitive classification. Thus, the physical characteristics of 3I Atlas carried within them the essence of the larger mystery, a form that would not be pinned down, a surface that both absorbed and reflected suspicion in equal measure. NASA's scientists found themselves studying not just an astronomical object, but a mirror that reflected back their own assumptions about what was possible in a universe that might be far stranger than any textbook had prepared them to imagine. Comets have always held a special place in human imagination, these icy wanderers that transform from invisible specks into spectacular celestial displays as they approach our sun. For centuries they carried both terror and wonder in their luminous tails, omens in the heavens that stirred the deepest fears and highest aspirations of civilizations across the globe. To planetary scientists, comets represent something less mystical but no less fascinating: pristine reservoirs of material from the early solar system, preserved in the deep freeze of space like cosmic time capsules waiting to reveal their secrets. When 3I Atlas was first announced to the astronomical community, many researchers expected it would behave like previous interstellar visitors, displaying the familiar characteristics of a comet as it drew closer to our sun's warming influence. Yet, in the months of observation that followed, the most troubling feature of the object was not what it revealed, but what it steadfastly refused to display: the complete absence of any cometary activity. When 3I Atlas was detected, astronomers anticipated that its designation might herald another spectacular display, another opportunity to study alien chemistry in action. As ices sublimated under solar heating, the expectation grew as careful tracking revealed its trajectory would bring it relatively close to the sun, well within the distance where even modest ice reservoirs should begin to outgas. If the object contained water ice, carbon dioxide, or any of the other volatile compounds that define cometary behavior, the increasing solar radiation should trigger eruptions of gas and dust that would bloom into a visible coma and stretch into the characteristic tail that makes comets so visually striking. Instead, the silence deepened with each passing observation. No coma appeared around the object, like a glowing atmosphere. No tail stretched behind it like a banner, announcing its passage. Telescopes captured only a stubborn point of light, flickering irregularly as it tumbled through space, but never blossoming into the ethereal display that defines true cometary nature. This refusal to behave according to expectation was deeply unsettling to NASA's observers, a violation of patterns that had held true for every comet ever studied. When celestial objects fail to follow the rules, when they exist in categories that seem to shift and blur, the very foundations of astronomical classification begin to tremble. Some researchers sought refuge in natural explanations that could preserve conventional understanding. Perhaps 3I Atlas was a fragment of solid rock with only trace amounts of volatile material, ices long since baked away during eons of exposure to cosmic radiation and starlight during its interstellar journey. Perhaps it had been heated repeatedly by close encounters with other stars during its wandering, each passage stripping away layers of ice until only refractory materials remained, leaving behind a core too depleted to produce visible outgassing. Such scenarios could explain why an object originating in the ice-rich outer regions of another stellar system might arrive in our neighborhood, appearing more like an asteroid than a comet, disguised by its own history of thermal processing. Yet, even these explanations strained under the weight of observation. If the object were truly depleted of volatiles, why did its brightness continue to fluctuate in ways that suggested ongoing surface activity? Why did its orbital motion show subtle deviations that hinted at forces beyond simple gravitational attraction? Others considered the possibility that sublimation might indeed be occurring, but in ways invisible to Earth-based instruments. Jets of gas could be firing from the object's surface, too small or too brief to generate a detectable coma, yet strong enough to alter its trajectory in measurable ways. This explanation offered one of the few plausible mechanisms for the non-gravitational acceleration that had been detected in 3I Atlas's motion, the same mysterious force that had puzzled researchers studying Oumuamua years earlier. Yet this scenario was also deeply unsatisfying. The absence of visible dust or vapor emissions contradicted the basic physics of cometary outgassing, processes that should scatter light and leave spectroscopic traces detectable by even modest instruments. The comparison to Borisov was particularly damning for conventional interpretations. That second confirmed interstellar visitor had behaved exactly as cometary theory predicted, displaying a bright coma, an unmistakable tail, and chemistry that was alien yet comprehensible within established frameworks. 2I/Borisov had reassured the astronomical community that nature elsewhere in the galaxy followed familiar rules, that the processes governing ice and dust in our solar system operated similarly around other stars. 3I Atlas systematically undid that reassurance, mocking the categories that researchers had carefully constructed to make sense of celestial wanderers. It occupied a liminal space between asteroid and comet, conforming to neither classification while exhibiting characteristics of both. In official papers, it would be described with careful hedging, words like ambiguous and anomalous that reflected scientific uncertainty without admitting to deeper fears. But in private discussions among colleagues, the language was often sharper and more direct. Unnatural was whispered in conversations, designed was suggested in speculative moments, wrong was felt even when not spoken aloud. The absent tail became a presence in its own right, a cosmic silence that spoke louder than any visible display. For if 3I Atlas was not behaving like a comet, then what exactly was it? A fragment of planetary crust stripped of ice by stellar violence, a metallic core from a destroyed asteroid, remnant of collisional catastrophe in another system, or something more deliberately crafted, a structure designed to endure the journey between stars without betraying its artificial nature through obvious outgassing? In astronomy, absence of evidence can be as significant as positive detection, particularly when that absence contradicts well-established expectations. The lack of cometary activity was not merely neutral data, it was a message written in the silence of vapor that should have appeared but never did. Philosophically, the refusal to conform to cometary behavior carried implications that extended far beyond the classification of a single object. Humanity has long relied on categories to understand the natural world, organizing the chaos of observation into manageable compartments labeled star, planet, moon, comet, asteroid. These labels provide psychological safety, transforming the overwhelming complexity of the cosmos into familiar territories that can be explored with confidence. But 3I Atlas tore at the edges of those comfortable compartments, existing in the spaces between categories like a cosmic refugee that belonged nowhere and everywhere simultaneously. It posed a question that traditional classification systems could not answer. What happens when nature refuses to cooperate with human attempts to organize reality? NASA's scientists logged the data with professional precision, calibrated their instruments with meticulous care, and wrote their reports in language carefully neutral and objective. But behind the technical terminology, the silence of the missing tail remained like an accusation. It was not merely a scientific puzzle requiring additional observation and analysis. It was a reminder that the universe does not promise to be legible, that cosmic visitors can arrive cloaked not only in physical distance and observational difficulty, but in outright defiance of humanity's most basic expectations about how matter behaves in space. And in that defiance lay the seed of deeper philosophical uncertainty, the recognition that perhaps 3I Atlas was not here to be understood according to existing frameworks, but to remind us how much our frameworks might need to change. If silence was unsettling in the optical spectrum, it was doubly so in the realm of radio astronomy. The prospect of collision with an unknown interstellar object was certainly troubling, but the implications of deliberate contact were potentially catastrophic in ways that transcended mere physical destruction. When NASA's Radio Astronomy Division first plotted the trajectory of 3I Atlas, relief came with the mathematical confirmation that it would pass safely by Earth, its hyperbolic orbit guaranteeing escape rather than impact. And yet the very fact that such an object had slipped into our solar system without advance warning, traveling at immense speed along an unpredictable trajectory, forced scientists to confront a terrifying truth about cosmic vulnerability. What if the next visitor does not miss? Our solar system bears the ancient scars of such encounters written in stone and metal across every airless surface. The craters that pockmark the moon are silent witnesses to cosmic violence, unweathered by atmosphere or geological activity, each one a permanent record of an impact that could just as easily have struck Earth. On our own planet, similar scars lie hidden beneath oceans and forests, masked by the constant recycling of our dynamic surface but detectable to those who know how to read the geological record. The Chicxulub crater, buried beneath Mexico's Yucatan Peninsula, born of an impact that ended the reign of dinosaurs and reshaped the entire biosphere. The Tunguska event of 1908, flattening thousands of square kilometers of Siberian forest with a force greater than the most powerful nuclear weapons ever detonated. These were impacts from local objects, comets and asteroids gravitationally bound to our solar system, traveling at speeds measured in tens of kilometers per second. But an interstellar wanderer like 3I Atlas moved at velocities far exceeding anything produced by solar system dynamics, carrying kinetic energy that scaled with the square of its tremendous speed. The calculations were genuinely chilling when considered in detail. A fragment only a few hundred meters across, traveling at the velocity observed for 3I Atlas, could release energy thousands of times greater than humanity's entire nuclear arsenal if it struck Earth directly. Larger objects, structures a kilometer or more in diameter, could potentially end technological civilization, perhaps even rendering our planet uninhabitable for complex life forms. The statistical rarity of such events provided only limited comfort to those who understood the physics involved. Danger does not cease to exist simply because it occurs infrequently. It merely waits longer between manifestations, building potential energy in the vast spaces between probability and occurrence. For NASA's planetary defense teams, the fear was immediate and practical, rather than abstract. The Asteroid Terrestrial Impact Last Alert System, the same network that had discovered 3I Atlas, was designed as humanity's final line of warning against cosmic catastrophe. Atlas and similar surveys were intended to provide days, weeks, or perhaps months of advance notice, should a dangerous object be detected on a collision course with Earth, time enough to attempt deflection or at least evacuation of impact zones. But 3I Atlas had revealed a fundamental weakness in this protective shield. It had entered the inner solar system essentially undetected until it was already close enough for detailed study, moving too fast and arriving too unexpectedly for any defensive response to be mounted. How many similar objects had passed through our neighborhood in the millennia before telescopic astronomy? How many more would slip by unnoticed in the future, invisible against the star field until the moment they became an immediate threat? And perhaps most unsettling of all, how much warning would humanity truly receive if one of these interstellar visitors was aimed directly at our world? There is a philosophical cruelty embedded in such scenarios that transcends mere physical catastrophe. Civilizations rise slowly over millennia, building knowledge, art, and cultural achievements through the patient accumulation of generational effort. Yet the cosmos holds within its vast indifference the power to erase all of that progress in a single moment. The random strike of a stone from another star system capable of reducing thousands of years of human development to geological sediment. The fear that haunted NASA's halls was not merely scientific, it was existential, touching the very foundations of what it means to build a technological civilization on a small planet in an infinite universe. But there was another layer of dread that some researchers hesitated to voice in official forums. If 3I Atlas represented something more than natural debris, If even a fraction of the speculation about artificial origin held any truth, then the scenario of collision carried implications that extended far beyond random cosmic violence. An interstellar probe crashing into Earth, whether by accident, malfunction, or deliberate intent, would not simply be a geological event, measurable in megatons of explosive force. It would be a message written in catastrophe, a signal carved directly into our planet's biosphere with the blunt instrument of kinetic energy. The fear shifted from statistical chance to the possibility of agency, from natural disaster to potential communication through the universal language of controlled destruction. For now, the trajectory calculations offered temporary comfort. 3 Ayatollahs would glide past our world, like a cosmic tourist, a visitor rather than an executioner, leaving only questions in its wake rather than craters. But the reassurance was conditional and fragile, dependent entirely on the assumption that the next interstellar visitor would also miss, that the universe would continue to deliver only messengers rather than instruments of annihilation. And in that assumption lay a vulnerability that no amount of technological advancement could completely eliminate. The spectre of collision became a quiet undertone in every discussion of 3 Ayatolahs, the nightmare that no one wanted to voice openly yet hovered behind every orbital calculation, every simulation run in the deep hours when the weight of cosmic responsibility pressed most heavily on human shoulders. For each hyperbolic intruder proved the same fundamental truth: the solar system is not a sealed sanctuary protected by distance and darkness. The universe does not ask permission before sending fragments of itself across the threshold of our cosmic neighborhood. The only question that remains is when the trajectory of one of these travelers will align not with harmless passage, but with Earth itself. Thus, the fear of 3 Ayatolahs extended beyond mere curiosity about its nature and origin. It was a reminder that safety in space is always an illusion, that civilization endures only by the grace of chance in a cosmos where probability and catastrophe dance together in equations too complex for comfort. The arrival of 3 Ayatolahs did not occur in cosmic isolation, a singular event to be studied and filed away in astronomical databases. In less than a single decade, humanity had witnessed 4 confirmed interstellar visitors: Oumuamua, Borisov, an object designated 3I/Discovery that had passed largely unnoticed, and now Watcher itself. Before 2017, not one interstellar object had ever been confirmed with certainty. To encounter 4 in such a brief span seemed to mock the very concept of statistical coincidence, challenging fundamental assumptions about the frequency of such visitations. For NASA scientists tasked with interpreting these cosmic arrivals, the repetition raised a haunting possibility that kept researchers awake during the quiet hours before dawn. Perhaps the galaxy was not the sparse desert punctuated by rare wanderers that models had predicted, but rather a river flowing with countless interstellar fragments that had always been there, slipping past unnoticed until humanity finally developed eyes sharp enough to see. The numbers alone were troubling when extrapolated across cosmic timescales. If 4 objects had been detected in such a short observation window, then statistical inference suggested that thousands, perhaps tens of thousands, must be passing through our solar system every century. Most would remain too faint, too small, or too swift for detection by current instruments, invisible ghosts in the cosmic wind. The solar system, once imagined as an isolated island of matter orbiting peacefully in the galactic suburbs, now appeared more like a busy intersection on an interstellar highway, every planet and moon immersed in this silent traffic of wandering debris. The realization fundamentally altered astronomy's comfortable assumptions about cosmic neighborhood dynamics. The pattern also raised deeper questions that struck at the heart of probability theory and observational selection effects. Was the apparent clustering of discoveries merely the inevitable result of improved telescopes and more sensitive sky surveys, humanity finally achieving the technological capability to detect what had always been present? Or was there something genuinely unusual about this particular epoch in galactic history? some alignment of cosmic dynamics that was funneling debris toward our stellar neighborhood with unprecedented frequency. If the latter possibility held even a grain of truth, then humanity might be living through an era of increased exposure to interstellar visitors, witnessing a cosmic phenomenon that occurs only rarely in the deep history of stellar systems. The implications of such temporal clustering were both fascinating and terrifying to contemplate. Some researchers dared to whisper scenarios that pushed beyond conventional astrophysics into realms that made conservative scientists deeply uncomfortable. If these objects were not entirely natural, if even one among them bore traces of deliberate design, then their arrival in such rapid succession could not be dismissed as mere coincidence. It would suggest coordination rather than chaos, intention rather than randomness, perhaps even systematic exploration or surveillance of our solar system, by intelligences whose capabilities and motivations remained utterly opaque. The idea was dangerous to entertain in professional settings, but it refused to vanish entirely from the darker corners of scientific speculation. Patterns have always provoked human suspicion of underlying purpose, the tendency to seek meaning in repetition that may reflect intelligence rather than chance. NASA's official position remained measured and conservative, as befitted a government agency responsible for maintaining public confidence in scientific methodology. The surge in interstellar discoveries was attributed publicly to observational improvements, the triumph of better instruments and more systematic surveys rather than any anomaly in cosmic dynamics. And yet, behind the closed doors of conference rooms, and in the margins of technical discussions, the unease lingered like smoke that could not be dispersed by official pronouncements. The pattern had already shifted humanity's fundamental perception of its place in the galactic order, regardless of whether that pattern reflected natural abundance or something more deliberately orchestrated. No longer could Earth be imagined as an untouched outpost on the cosmic frontier, isolated and unnoticed in the vast darkness between stars. Instead, our world appeared to be part of an active network, a location through which messengers drifted with surprising regularity, carrying news from stellar systems we might never visit. Their presence was undeniable, their origins mysterious, and their implications profoundly unsettling. The philosophical weight of this recognition pressed against the boundaries of human understanding like water against a dam. Our species has always sought meaning in patterns, finding constellations in random star arrangements, cycles in the chaos of weather, purpose in the apparent design of natural systems. To discover a pattern in interstellar arrivals was to confront the possibility that the cosmos itself might be engaged in some form of dialogue with humanity, whether through the blind mechanics of natural processes or the deliberate actions of unseen intelligences. And yet this was not a pattern that offered comfort or reassurance about humanity's cosmic significance. It spoke instead of intrusion, of vulnerability, of a universe far more crowded and restless than the textbooks had promised students. In this new context, 3I Atlas represented more than a single astronomical object requiring analysis and classification. It had become part of a larger chorus, its silent voice joining those of Oumuamua, Borisov, and the others in a cosmic symphony whose meaning remained tantalizingly beyond human comprehension. Together they sang of a galaxy in constant motion, alive with fragments and perhaps intentions that made the boundaries of our solar system seem as porous as morning mist. And so the fear deepened beyond concern for any individual visitor, expanding into recognition that 3I Atlas's arrival was not unique, but representative, not an anomaly but a harbinger of countless others yet to come. In the sterile corridors of NASA facilities around the globe, this recognition hardened into a new form of vigilance, the understanding that if 4 had come within human detection capability, then the next decade would inevitably bring more. Each new arrival would sharpen the same fundamental question that 3I Atlas had posed. What story is the galaxy trying to tell through these wandering messengers? And perhaps more importantly, are we prepared to understand that story when it finally becomes clear? When the conventional data of 3I Atlas refused to yield to ordinary explanations rooted in familiar astrophysics, some theorists began to reach toward the more speculative frontiers of modern cosmology, regions where speculation meets the unknown in uncomfortable proximity. Among the most provocative ideas circulating in hushed discussions was the possibility that the object's peculiar behavior might be influenced by dark matter, the invisible scaffolding that supposedly accounts for the majority of mass in the observable universe. Dark matter remains one of the great mysteries of modern physics, a substance that does not emit, absorb, or scatter electromagnetic radiation in any detectable way, yet whose gravitational influence shapes the rotation of galaxies and the large-scale structure of cosmic evolution. Could it be that 3I Atlas was carrying within its journey the fingerprints of this hidden architecture, offering humanity an unprecedented opportunity to study dark matter's effects on the motion of individual objects? The speculation began with the object's documented anomalies, the faint but persistent deviations from purely gravitational motion that had puzzled analysts since the first orbital calculations. These unexplained accelerations could not be attributed to outgassing, solar wind pressure, or any other conventional mechanism. But if 3I Atlas had passed through regions of space where dark matter concentrated in unusual densities, its trajectory might have been nudged in subtle ways that accumulated over the vast distances of interstellar travel. Small perturbations, imperceptible across light years of empty space, could manifest as the orbital anomalies now being detected by Earth's most sensitive instruments. In this interpretation, the interstellar visitor became less a messenger from another stellar system, and more an accidental probe, delivering data about the invisible currents that flow through galactic space like cosmic trade winds. Some theorists pushed this line of reasoning even further into speculative territory. If dark matter is not uniformly distributed throughout the galaxy, but instead clumps into filaments, halos, and other structural forms, then 3I Atlas might have encountered such concentrations during its million-year journey between stars. The scars of that encounter, its unusual trajectory, its deceptive brightness variations, its resistance to easy classification, could represent evidence written not in conventional matter, but in the gravitational signatures of the universe's hidden mass. In this vision, every interstellar wanderer becomes an unintentional explorer, carrying information about phenomena that Earth-based instruments have never directly detected. The idea was tantalizing to researchers frustrated by dark matter's stubborn refusal to reveal itself through conventional observation, but it also carried implications that extended far beyond academic curiosity. If interstellar objects are constantly being shaped by encounters with dark matter structures, then every visitor that enters our solar system may be influenced by forces that remain completely beyond human understanding. To observe these wanderers is to peer into cosmic processes that operate according to rules we have barely begun to comprehend, a humbling reminder that our equations and models may describe only the visible surface of a much deeper and stranger reality. NASA's physicists approach such ideas with the caution that scientific training demands, recognizing that dark matter remains largely hypothetical despite its apparent necessity for explaining galactic dynamics. To invoke its influence in the case of 3I Atlas was to venture onto speculative ground where mathematics becomes philosophy and observation blends uncomfortably with imagination. Yet the persistent anomalies demanded some form of explanation, and traditional models strained under the weight of observations that refused to conform to expectations based on familiar physics. Better perhaps to entertain possibilities involving invisible forces than to torture visible phenomena into unnatural conformity with incomplete theories. For the general public, such discussions rarely surfaced in popular press coverage or educational outreach programs. The technical complexity of dark matter physics makes it unsuitable for casual explanation, and the speculative nature of its connection to interstellar visitors makes it inappropriate for definitive public statements. Yet, within scientific circles, the possibility carried a quiet sense of significance that transcended its uncertain foundation in observational evidence. What if each wandering object like 3i Atlas were not merely a fragment of distant geology, but also a test particle revealing the hidden topography of galactic structure? To chart their paths with sufficient precision might eventually mean mapping the unseen skeleton upon which visible matter hangs like decorations on an invisible tree. Philosophically, the connection to dark matter deepened rather than resolved the enigma surrounding 3i Atlas's nature and behavior. Dark matter has always represented the great unknown in cosmology, the invisible majority of cosmic substance that shapes everything yet reveals itself only through indirect gravitational effects. To imagine 3i Atlas as marked by encounters with this hidden realm was to confront an unsettling truth about the universe's fundamental nature, that reality is more ghostly than solid, more unseen than visible, more mysterious than any human theory has yet managed to capture. The object's anomalies cease to be merely puzzling deviations from expected behavior, becoming instead windows into an abyss of ignorance that yawned beneath even the most sophisticated scientific understanding. And so the whispers of dark matter influence joined the growing chorus of explanations for 3i Atlas's strange properties, none definitive, all unsettling in their implications. Perhaps the visitor was nothing more than an ordinary shard of rock and ice behaving oddly due to surface irregularities. Perhaps it was a relic of stellar violence or technological design. Or perhaps it was simply the first messenger to reveal that the paths of the universe are written not only by visible stars and planets, but also by the vast invisible structures that hold the cosmos together in ways we are only beginning to suspect. In this interpretation, NASA's growing unease about 3i Atlas reflected not just uncertainty about a single object, but recognition that reality itself might be governed by forces as hidden as they are fundamental. The visitor was a riddle wrapped in an enigma, but also a reminder that the cosmos operates according to principles that remain largely invisible to human observation, no matter how sophisticated our instruments become. The most unnerving aspects of 3i Atlas lay not in its dramatic characteristics, though those were certainly troubling enough, but in the tiny, persistent deviations that appeared when its motion was compared against the pristine predictions of gravitational theory. NASA's teams, working in collaboration with observatories around the globe, had compared thousands of precise measurements against the mathematical models that had successfully described planetary motion for centuries. The predictions should have been flawless. Gravity is perhaps the most thoroughly understood force in physics, its equations leaving little room for ambiguity or surprise. But 3i Atlas refused to obey those equations with the precision that centuries of astronomical observation had taught scientists to expect. The deviations were subtle, fractions of an arc-second in angular position, minute shifts in timing that required atomic clocks to detect, but they were persistent and systematic rather than random. Each new observation confirmed what astronomers least wanted to admit. The object was not moving exactly as gravitational theory predicted it should. Non-gravitational forces were the obvious explanation for such discrepancies, but the usual suspects remained frustratingly invisible. Outgassing from sublimating ice should produce detectable vapor clouds. Solar-wind interactions should correlate with distance from the sun. Radiation pressure should vary predictably with surface orientation and reflectivity. None of these mechanisms appeared to be operating in ways that could account for 3i Atlas's orbital irregularities. The object was accelerating as if nudged by forces that left no other trace of their existence, influenced by phenomena that operated beyond the detection limits of even the most sensitive instruments. To NASA scientists trained to find natural explanations for astronomical anomalies, the persistent deviations recalled uncomfortable parallels with previous mysteries that had challenged the foundations of physics. The Pioneer anomaly had once suggested that spacecraft were experiencing tiny, unexplained accelerations as they traveled toward the outer solar system, deviations that persisted for years before finally being attributed to thermal radiation from the spacecraft themselves. But 3i Atlas was not a human-built spacecraft with internal heat sources and asymmetric thermal emission patterns. It was supposed to be a natural object, governed by forces that should be entirely predictable according to well-established physical laws. If a natural body was exhibiting similar anomalies, then what did that imply about the completeness of humanity's understanding of motion in space? Alternative explanations strained credibility when subjected to detailed analysis. Some researchers suggested that uneven surface reflectivity might create radiation pressure imbalances, sunlight pushing more strongly on certain facets than others, as the object tumbled through space. But for the observed accelerations to result from such effects, the geometry would need to be extraordinarily thin and precisely oriented, almost Say-like in its ability to catch and redirect solar photons. Others considered the possibility of interactions with the tenuous interplanetary medium, dust grains, magnetic fields, or charged particles that might exert subtle forces on a rapidly moving object. But detailed calculations showed that such mechanisms were far too weak to produce the observed effects, requiring densities of interplanetary material orders of magnitude higher than actually measured. Each potential explanation closed one avenue of inquiry only to open pathways toward even more disturbing possibilities. The gravitational anomalies were not catastrophic in magnitude, but they struck at the heart of scientific certainty about the most fundamental force in the universe. Gravity has been the one law that the cosmos has seemed to obey without exception, from the orbital mechanics of planets to the stately rotation of entire galaxies. To witness even subtle violations of gravitational prediction was to feel the conceptual ground trembling beneath the entire edifice of physics. NASA's orbital analysts grew increasingly cautious in their public statements, speaking of residuals and uncertainties, rather than acknowledging the more troubling possibility that something was systematically pushing 3I Atlas in ways that defied conventional understanding. Yet the truth beneath the careful language was becoming impossible to ignore. Something was influencing the object's motion, and the nature of that influence remained completely mysterious. In scientific circles where reputation and career advancement depend on conservative interpretation of data, the anomaly became a source of quiet obsession, discussed in private conversations, and explored in unpublished analyses that pushed against the boundaries of respectable speculation. Could the deviations be evidence of exotic physics operating at scales larger than laboratory experiments could test? Modified gravity theories that operated differently in the weak field regime of interstellar space? Quantum effects that became significant only over cosmic distances and timescales? Or was the explanation more prosaic, but no less unsettling, evidence that 3I Atlas was not entirely natural in origin, its motion subtly guided by technology sophisticated enough to mimic gravitational acceleration while remaining invisible to direct detection? The thought was uncomfortable for scientists trained to seek natural explanations for observed phenomena, but it shadowed every discussion of the orbital anomalies like an uninvited guest at a formal dinner. For the public, safely insulated from the technical details of orbital mechanics, the gravitational deviations remained invisible, buried in equations too complex to capture widespread attention. But for those at NASA and partner institutions who specialized in precision trajectory analysis, they were observing behavior that challenged the most fundamental assumptions about how objects move through space, patterns that suggested the universe still held secrets that centuries of physics had failed to uncover. Philosophically, the gravitational anomalies raised questions that extended far beyond the mechanics of a single interstellar visitor. Humanity has long believed that nature operates according to discoverable laws, that the cosmos can be described through mathematical relationships that reveal underlying order beneath apparent chaos. To encounter an object that subtly but persistently violated those mathematical predictions was to glimpse the possibility that the universe might be more complex, more layered, more fundamentally mysterious than even the most speculative theories had suggested. The deviations were not large enough to trigger public alarm or media sensation, but they were consistent enough to gnaw at scientific confidence in ways that no amount of careful analysis seemed capable of resolving. And so, in the margins of official reports, and the whispered conversations that occur in observatory hallways after formal presentations, the anomalies of 3I Atlas became symbols of humanity's continuing ignorance about the cosmos. They served as reminders that despite centuries of scientific progress, despite instruments capable of detecting gravitational waves and imaging black holes, the universe could still surprise us with phenomena that operated just beyond the edge of human understanding. The visitor had crossed into our solar system as if to deliver a message written in the subtle language of orbital mechanics. Your laws are approximations, your certainties are provisional, your understanding remains incomplete. The whisper that trailed behind 3I Atlas like a cosmic shadow was not merely about rock, ice, or gravitational dynamics. It was about the possibility of design. Within NASA's research community, most scientists maintained careful public neutrality, avoiding speculation that could undermine institutional credibility or trigger premature conclusions. Yet the object's systematic refusal to conform to natural categories, its persistence in defying both cometary and asteroidal classification, invited questions that conservative methodology could not entirely suppress. What if it was not natural at all? The Oumuamua had already cracked open this particular door of speculation with its own catalogue of anomalies, its unprecedented shape, its unexplained acceleration, its complete lack of visible outgassing, all had led to controversial suggestions by researchers like Avi Loeb that it might represent alien technology rather than natural debris. That hypothesis had been largely dismissed by the mainstream astronomical community as premature and insufficiently supported by evidence, but it had never been definitively disproven either. And when 3I Atlas arrived carrying its own collection of puzzling characteristics, the ghost of that earlier speculation returned with renewed intensity. The parallels were difficult to ignore for anyone who studied both objects systematically. Irregular brightness variations that resisted simple geometric interpretation, suspicious accelerations that could not be attributed to conventional outgassing, spectroscopic signatures that remained ambiguous despite intensive analysis. It was as though a pattern was forming in the data, each new interstellar visitor arriving with a similar signature of strangeness that defied natural explanation. In closed-door discussions among NASA's senior scientists, the possibility of artificial origin could not be dismissed as easily as it might be in public forums. The accumulated anomalies demanded some form of explanation, and if natural mechanisms proved inadequate, then artificial mechanisms became a logical alternative to consider. What if 3I Atlas represented technology rather than geology, engineering rather than natural processes, intention rather than cosmic accident? The implications of such a possibility radiated outward through every aspect of human understanding like shock waves through still water. A natural fragment from another stellar system was scientifically fascinating but philosophically manageable, evidence of cosmic processes operating beyond our direct observation. But a technological artifact would represent something qualitatively different, proof that intelligence existed elsewhere in the galaxy, and had achieved capabilities that included interstellar travel or communication. Even if the object were ancient and non-functional, a technological fossil drifting through space long after its creators had vanished, its mere existence would transform humanity's understanding of its place in the cosmic order. For NASA, the institutional weight of such speculation was nearly unbearable. To suggest alien technology on the basis of limited evidence would invite ridicule from the scientific community and potentially undermine public confidence in the agency's judgment. Yet to ignore the possibility entirely would risk overlooking what might be the most significant discovery in human history: contact with evidence of non-terrestrial intelligence, even if that contact was one-sided and indirect. The line between scientific caution and willful blindness grew increasingly difficult to navigate as more data accumulated. The history of astronomy provided both encouragement and warning for such radical speculation. When pulsars were first discovered, their precisely regular radio emissions were so unlike any known natural phenomenon that researchers half-jokingly designated them LGM for little green men. Only later did theoretical work identify them as rapidly rotating neutron stars, natural objects whose extreme physics produce the observed signals through entirely conventional electromagnetic processes. Perhaps 3I Atlas would follow a similar trajectory, strange and inexplicable now, but eventually yielding to natural explanation once human understanding advanced sufficiently. But the pulsar analogy also carried a subtle warning embedded within its apparent reassurance. Not every mysterious signal need be natural in origin, and the assumption that strange phenomena will always resolve into familiar physics might itself be a form of intellectual bias that could blind observers to genuine anomalies. To leap too quickly toward comfortable explanations might mean missing evidence of something truly extraordinary, something that challenged the fundamental assumptions underlying scientific methodology itself. If 3I Atlas were indeed artificial in origin, then its implications would extend far beyond astronomy into realms of philosophy, politics, and even theology. Humanity had always wondered whether intelligence existed elsewhere in the universe, but the question had remained safely abstract, confined to radio searches and theoretical speculation. Here, potentially, was a concrete answer, drifting silently through our own solar system, close enough to study with existing instruments, yet remote enough to avoid immediate confrontation or communication. But the possibilities diverged wildly depending on the nature and age of any hypothetical technology. The object could represent ancient wreckage, the fossilized remains of engineering projects completed millions of years ago by civilizations that had long since vanished from the galactic stage. It could be a probe designed for observation and data collection, functional but deliberately unobtrusive, designed to study solar systems without interfering with their natural development. Or it could be something more ominous, a scout or reconnaissance device, mapping potential targets for future contact or colonization by intelligences whose intentions remained utterly alien to human comprehension. Each scenario carried its own burden of implication and uncertainty, none of them entirely comfortable for a species that had grown accustomed to imagining itself alone in the cosmos. Even if artificial, the silent nature of 3I Atlas left all possibilities equally open and equally unverifiable. Without clear communication signals or obvious technological signatures, the object's true nature might remain forever ambiguous, suspended between categories like Schrödinger's cosmic cat. NASA's fear then was not merely of proof that would settle the question definitively, but of perpetual ambiguity that would never provide closure or certainty. The agency could continue to catalogue 3I Atlas's properties and track its trajectory with increasing precision, but the fundamental question of whether humanity was observing natural debris or technological artifacts might remain unanswerable regardless of how much data was collected. And in that persistent uncertainty lay perhaps the deepest source of unease, the recognition that some mysteries might be designed to remain mysterious, some visitors intended to inspire questions rather than provide answers. The speculation surrounding 3I Atlas did not develop in isolation from broader trends within the astronomical community, trends that had been quietly gaining momentum even before the object's discovery was announced to the world. The search for technosignatures, evidence of alien engineering rather than alien voices, had emerged as a legitimate field of scientific inquiry in the wake of Oumuamur's controversial characteristics. Chief among these new initiatives was the Galileo Project, a bold research program spearheaded by Harvard's Avi Loeb that sought to study unidentified aerial phenomena and interstellar objects using the rigorous methodologies of astrophysics, rather than the speculation that had long dominated discussions of potential alien visitation. To many within NASA's traditional research structure, the Galileo project represented both opportunity and risk, a chance to explore questions that had been relegated to the margins of respectable science, but also a potential source of controversy that could damage institutional credibility if pursued too aggressively. The project walked a precarious line between scientific daring and professional suicide, seeking to apply legitimate astronomical techniques to phenomena that had historically been dismissed as either natural anomalies or popular delusions. Yet the repeated arrival of interstellar objects with puzzling characteristics had begun to lend weight to arguments that systematic investigation was warranted, even if that investigation ultimately confirmed natural rather than artificial explanations. If Oumuamua had been dismissed too hastily by a scientific community reluctant to consider uncomfortable possibilities, and if Three-Eye Atlas now carried echoes of the same anomalies, then perhaps the systematic search for artificial signatures was not as reckless as conservative astronomers had initially believed. The fear was not only of professional ridicule, but of being unprepared for what might prove to be the most important discovery in human history. Technosignature research fundamentally shifted the conceptual framework within which interstellar visitors were analyzed and interpreted. Instead of waiting for alien civilizations to broadcast intentional radio messages across the galaxy, scientists began to consider artifacts, probes, or even debris as equally valid evidence of non-terrestrial intelligence. A reflective solar sail drifting between stars, a fragment of ancient spacecraft too degraded to function but still recognizable as artificial, even pieces of interstellar infrastructure too exotic to comprehend, all would speak of intelligence operating on galactic scales. In this expanded framework, Three-Eye Atlas became more than an astronomical curiosity requiring classification within existing categories. It became a potential test case for methodologies designed to distinguish between natural and artificial phenomena in deep space. NASA itself had to navigate these waters with extraordinary care, balancing institutional responsibility against scientific opportunity. Publicly, the agency continued to emphasize natural explanations for interstellar visitors, maintaining the conservative approach that had served it well throughout decades of space exploration. But privately, researchers collaborated with independent initiatives like the Galileo Project, sharing data, refining analytical techniques, and contributing to the development of protocols that might one day prove crucial for recognizing genuine technological artifacts. The line between official acknowledgement and informal cooperation grew increasingly blurred as the anomalies associated with Three-Eye ATLAS accumulated beyond what could comfortably be explained through conventional astrophysics. The historical parallels were not lost on those who remembered how Galileo's telescopic observations had once shattered the comfortable assumptions of his era, revealing moons orbiting Jupiter and phases of Venus that contradicted the geocentric model of the universe. The Galileo Project's name was chosen deliberately, honoring a tradition of challenging established paradigms when evidence demanded new explanations, even if those explanations made authorities uncomfortable. In the context of Three-Eye Atlas's discovery, the project's mission seemed almost prophetic, as though the universe had provided a test case specifically designed to validate or refute the search for technological signatures among interstellar visitors. Still, institutional fear tempered any enthusiasm that might have developed around such possibilities. To publicly endorse the search for alien artifacts was to invite scrutiny that could damage careers and institutional funding, particularly if that search ultimately proved fruitless or misguided. The scientific community had long memories for researchers who had pursued exotic explanations for natural phenomena, cautionary tales of careers derailed by speculation that outran evidence. And yet the alternative, ignoring potentially revolutionary discoveries out of professional caution, carried its own risks and ethical implications. If genuine evidence of alien technology was drifting through the solar system, if humanity's first contact with non-terrestrial intelligence was occurring through passive observation of interstellar artifacts, then the failure to recognize and study such evidence would represent a tragedy of missed opportunity beyond calculation. Philosophically, the resonance between Three-Eye Atlas and the broader technosignature research program underscored a fundamental truth about the nature of scientific discovery, that evidence often arrives before theories are prepared to interpret it correctly. Science is not merely about collecting data, but about developing the conceptual frameworks and analytical tools necessary to recognize significance when it appears. The fear surrounding 3I Atlas was thus not only fear of the unknown, but fear of the inadequacy of human knowledge to properly evaluate what the universe was revealing. Whether the object represented natural debris or technological artifact, its passage through the solar system had already served as a catalyst for expanding the boundaries of astronomical investigation. The whispers of artificial origin might prove entirely unfounded, but they had succeeded in forcing the scientific community to confront questions that had previously been relegated to science fiction rather than serious research. And in that sense, 3I Atlas had already achieved a kind of success, not as a messenger bearing clear communication from alien civilizations, but as a cosmic riddle that challenged humanity to think more broadly about what forms evidence of intelligence might take when it arrived from the depths of interstellar space. Thus, in the sterile corridors of NASA facilities around the world, the shadow of the Galileo project lengthened with each new anomaly detected in the object's behavior, serving as a reminder that the universe does not always conform to human expectations, and that the most important discoveries often emerge from the willingness to ask forbidden questions rather than seek comfortable answers. As the debates surrounding 3I Atlas continued to evolve within scientific circles, a quieter but perhaps more profound interpretation began to take shape among researchers willing to think in geological rather than technological timescales. What if the object represented neither active technology nor natural debris, but something intermediate between these categories? The fossilized remains of civilizations that had vanished from the galaxy long before Earth's sun had finished forming from its stellar nursery. The concept of cosmic archaeology, the search for artifacts and remnants of extinct intelligences, offered a framework for understanding interstellar visitors that avoided the uncomfortable implications of active surveillance, while acknowledging the possibility that the galaxy might be littered with evidence of its own deep history. Civilizations rise and fall on Earth with predictable regularity, their monuments weathering into dust, their technologies becoming obsolete, their languages forgotten by subsequent generations. Why should the pattern be different among the stars? If intelligent life had ever flourished elsewhere in the galaxy, if technological species had achieved interstellar capabilities millions or billions of years ago, then time itself would ensure that most of that intelligence was now extinct, leaving only scattered remnants drifting through space like cosmic fossils. The silence that humanity perceives when listening to the galaxy might not be evidence of our cosmic solitude, but rather the echo of extinctions so ancient that even their ruins have been worn smooth by the passage of eons. In this interpretation, interstellar objects like 3I Atlas might represent archaeological specimens, fragments of engineering projects that had been launched during epochs when the galaxy was younger and perhaps more densely populated with technological civilizations. The idea carried both wonder and melancholy in equal measure, offering the possibility of contact with intelligence, while simultaneously emphasizing the ultimate futility of all technological achievement. Human civilization had already demonstrated the principle on a smaller scale, launching thousands of probes, satellites, and fragments of technology into Earth orbit and beyond. 1,000,000 years from now, long after human cities had crumbled and human languages had been forgotten, those artifacts might still be drifting through the solar system. Some would undoubtedly shatter from impacts with debris, becoming indistinguishable from natural meteoroids. Others might endure, their shapes eroded by cosmic radiation and micrometeorite bombardment, but their fundamental geometry still hinting at purposeful design. To an alien observer discovering such relics, they would present exactly the kind of interpretive challenge that 3I Atlas now posed to human astronomers, objects that might be natural or artificial, ancient or recent, significant or merely curious. NASA scientists entertained these possibilities with the caution that scientific methodology demands, recognizing that speculation about extinct civilizations was inherently unverifiable and thus dangerous territory for researchers whose reputations depended on empirical evidence. But they also understood that science advances not only through measurement and calculation, but also through the expansion of conceptual frameworks that allow new kinds of evidence to be recognized and interpreted. To ask whether 3I Atlas might be an archaeological specimen was not to claim certainty about its origin, but to acknowledge that the universe might already contain a museum of its own lost civilizations, waiting for observers sophisticated enough to recognize the exhibits. The fear associated with this interpretation was subtler than the immediate dread of active surveillance or technological threat, but it was also more existentially profound in its implications. If the galaxy was indeed littered with the fossilized remains of intelligence, if civilizations inevitably arose, flourished briefly, and then vanished, leaving only scattered debris, then humanity was not unique in achieving technology, but it was also not exempt from the ultimate fate that had befallen all previous intelligences. The cosmic archaeological perspective transformed 3I Atlas from a potential harbinger of alien contact into a memento mori, a reminder, written in the universal language of orbital mechanics, that all civilizations are temporary, all achievements eventually forgotten, all technological works destined to become indistinguishable from natural phenomena. Even the ambiguity of the object's classification became meaningful within this framework. If Earth's most sophisticated instruments could not determine whether 3I Atlas was natural or artificial, then how many similar relics had already passed through the solar system unrecognized, classified as asteroids or comets, when they might actually have been the remnants of technological projects whose purposes and creators had been lost to time? The act of observation itself became a form of archaeology, the careful excavation of meaning from data that might contain traces of intelligence so ancient that its recognition required new forms of scientific sensitivity. Cosmic archaeology demanded humility rather than certainty, the willingness to admit that the distinction between natural and artificial might blur beyond recognition when viewed across sufficient expanses of time. And so, in considering 3I Atlas as a potential relic of galactic history, the fear shifted from immediate concerns about surveillance or contact to deeper reflections on the nature of intelligence itself and its ultimate significance in cosmic evolution. Was consciousness merely a brief flicker in the universe's development, a temporary complexity that emerged from matter and energy before dissolving back into simpler forms, or did intelligence leave permanent marks on reality, signatures that could persist even after their creators had returned to dust? The silent passage of 3I Atlas through human detection systems offered no clear answers to such questions, but it served as a profound reminder that humanity might be surrounded by evidence of its own future fate, drifting through space in forms too weathered and ancient to be easily recognized. In this light, the object became simultaneously hopeful and terrifying, proof that intelligence could achieve interstellar reach, but also evidence that such achievements might be as temporary as everything else in a universe governed by entropy and time. When conventional explanations for 3I Atlas's behavior proved inadequate to account for its observed properties, some theoretical physicists began to explore possibilities that pushed the boundaries of established science into realms where speculation bordered on science fiction. Among the most exotic hypotheses circulating in informal discussions was the notion that the object might contain or consist of exotic matter, substances with properties fundamentally different from anything found in terrestrial experience or conventional astrophysical environments. Exotic matter had long been a staple of theoretical physics, materials with negative mass or energy density, particles that interacted with gravity in unconventional ways, or structures that operated according to quantum mechanical principles scaled up to macroscopic sizes. Such substances remained largely hypothetical, mathematical constructs that satisfied certain equations but had never been detected or synthesized under laboratory conditions. Yet the persistent anomalies in 3I Atlas's motion and appearance suggested that it might represent humanity's first encounter with matter that behaved according to rules not yet incorporated into the standard model of particle physics. If the object contained even small amounts of exotic material, substances that had been stabilized under conditions that could not be replicated in terrestrial laboratories, then its behavior might suddenly make sense within an expanded framework of physical law. The irregular acceleration could result from interactions between exotic matter and conventional gravitational fields, producing forces that appeared mysterious only because human science lacked the theoretical foundation to recognize them. The ambiguous spectroscopic signatures might reflect quantum interference effects between exotic and normal matter, creating optical properties that had no analogue in familiar experience. Even the object's apparent resistance to classification might be a natural consequence of its hybrid composition, simultaneously natural in the sense of being produced by physical processes, yet artificial in the sense of being composed of materials that could only exist under extraordinary conditions. Some researchers speculated that exotic matter might serve as a signature of advanced technological civilizations, the inevitable result of engineering projects that pushed the boundaries of materials science beyond what organic chemistry could provide. If intelligent species consistently discovered methods for synthesizing exotic substances, then such materials might be as characteristic of technological development as radio emissions or atmospheric pollution. To detect exotic matter in an interstellar visitor would thus represent a form of technological signature, evidence of capabilities that far exceeded anything humanity had achieved, even if the object itself was no longer actively controlled by its creators. NASA's theoretical physicists approached such ideas with even greater caution than they applied to speculation about conventional alien technology, recognizing that exotic matter remained largely unproven even in theoretical contexts. To invoke its presence as an explanation for 3I Atlas's properties was to venture into territory where mathematics became increasingly disconnected from experimental verification, a dangerous realm for researchers whose careers depended on maintaining credible connections between theory and observation. Yet, the accumulating anomalies demanded some form of explanation that could account for behavior that conventional physics seemed unable to describe adequately. And if that explanation required expanding the boundaries of known science, then perhaps the fault lay not with the speculation, but with the limitations of current human understanding. The philosophical implications of exotic matter were as unsettling as its potential technological applications, suggesting that reality itself might be more malleable and complex than humanity had ever imagined. If matter could exist in forms that violated basic assumptions about mass, energy, and gravitational interaction, then the universe was not merely larger and older than human comprehension, but fundamentally stranger in its basic operating principles. The fear associated with such possibilities extended beyond concerns about alien technology or cosmic archaeology into more fundamental questions about the nature of physical law itself. Were the equations that govern terrestrial physics merely local approximations, valid only within the narrow range of conditions that existed in Earth's immediate cosmic neighborhood? Might the galaxy be filled with phenomena that operated according to principles so exotic that human science would require centuries or millennia to develop adequate theoretical frameworks for their comprehension? 3I Atlas, in this interpretation, became not merely a visitor from another stellar system, but potentially an emissary from a realm of physics that humanity had not yet learned to recognize or understand. Its silent passage through the solar system would then represent more than a close encounter with alien matter. It would be an introduction to alien physics, carried in the form of substances that challenged the very foundations of scientific knowledge. The object's refusal to conform to established categories was thus not a failure of human observation or classification, but a natural consequence of encountering matter that operated according to rules not yet written in any textbook. And so the whispers of exotic matter joined the growing catalogue of explanations for 3I Atlas's mysterious properties, each more speculative than the last, yet each offering the possibility that the visitor represented something qualitatively different from anything in human experience. Whether the object contained exotic matter, conventional materials arranged in unusual configurations, or something else entirely, Its passage had already succeeded in forcing the expansion of scientific imagination beyond the comfortable boundaries of established knowledge. The universe, it seemed, was determined to remain stranger than theory could easily accommodate, and 3I Atlas was simply the latest reminder that reality consistently exceeded the limits of human understanding. If Einstein's gravitational field equations provided the mathematical framework for understanding 3I Atlas's trajectory through space, then the subtle deviations from those predictions served as a reminder that even the most successful theories in physics might be incomplete descriptions of cosmic reality. Einstein's theory of general relativity had been humanity's most successful description of gravity for more than a century, accurately predicting the motion of planets, the bending of light around massive stars, and the gravitational waves produced by colliding black holes. It represented the pinnacle of theoretical physics, a mathematical poetry that unified space, time, matter, and energy into a single elegant framework that seemed to describe the fundamental structure of reality itself. Yet 3I Atlas, in its subtle but persistent refusal to obey purely gravitational motion, seemed to whisper that even Einstein's masterpiece might be merely an approximation, accurate under most conditions, but incomplete when confronted with phenomena that operated at the margins of current understanding. The hyperbolic trajectory itself posed no challenge to relativity. The theory easily accommodated the motion of interstellar fragments following open orbits around the Sun, but the small residual accelerations, the unexplained deviations that accumulated over months of careful observation, suggested forces or effects that had not been incorporated into Einstein's equations. It was not that relativity was wrong in any fundamental sense, but rather that it might be incomplete, describing only a subset of the gravitational phenomena that operated in the universe. Einstein himself had often acknowledged that his theory was unfinished, a stepping stone towards some more complete understanding that would eventually unify gravity with quantum mechanics and explain the relationship between matter, energy, space, and time in ways that remained elusive despite decades of theoretical effort. He had dreamed of a theory of everything, a single mathematical framework that would describe all physical phenomena from the smallest quantum fluctuations to the largest cosmic structures. But that dream had died with him, and subsequent generations of physicists had made only limited progress toward the unified theory he had envisioned. Now, as 3I Atlas traced its anomalous path through the solar system, its motion seemed to press against the same gaps in understanding that had frustrated Einstein throughout his later career. Perhaps the object's deviations were hints of quantum gravitational effects that became significant only over interstellar distances, corrections to Einstein's equations that were too small to detect in laboratory experiments, but accumulated into measurable effects during million-year journeys between stars. Perhaps they reflected interactions with dark energy, the mysterious force that appeared to be accelerating the expansion of the universe itself, operating through mechanisms that remained completely unknown to human physics. Or perhaps they suggested modifications to the theory of gravity itself, adjustments to Einstein's equations that would be necessary to describe gravitational phenomena in regimes where general relativity had never been thoroughly tested. NASA's theoretical teams entertained all of these possibilities, with the mixture of excitement and trepidation that accompanies any challenge to fundamental physics, recognizing that revolutionary discoveries often emerge from the investigation of small anomalies that resist explanation within existing frameworks. The history of science was filled with examples of tiny discrepancies that had eventually led to major theoretical breakthroughs. The precession of Mercury's orbit that had pointed toward general relativity, the blackbody radiation spectrum that had inspired quantum mechanics, the cosmic microwave background that had validated Big Bang cosmology. Perhaps 3I Atlas's orbital anomalies would eventually be remembered as the first hint of some new physics that would transform human understanding of gravity and motion, just as the photoelectric effect had once pointed toward the quantum nature of light. Yet such speculation carried its own burden of uncertainty and fear. For revolutionary discoveries were also inherently destabilizing, overturning comfortable assumptions and forcing the reconstruction of knowledge that had seemed secure. If Einstein's equations were indeed incomplete, if gravity operated according to principles more complex than current theory could accommodate, then the implications extended far beyond the motion of a single interstellar visitor. The entire framework of cosmological understanding, from the behavior of galaxies to the ultimate fate of the universe, might require fundamental revision in light of new gravitational phenomena. Such possibilities were simultaneously thrilling and terrifying to physicists who had devoted their careers to mastering the current theoretical landscape, offering the prospect of revolutionary insights while threatening to render decades of previous work obsolete. Philosophically, the potential inadequacy of Einstein's theory served as a humbling reminder that even the most successful scientific frameworks were provisional, accurate descriptions of observed phenomena rather than final truths about the nature of reality. Physics had always advanced through the recognition that existing theories were approximations, useful tools for understanding limited domains of experience, but incomplete descriptions of the full complexity of the universe. Newton's mechanics had given way to Einstein's relativity, when observations demanded greater accuracy, and Einstein's framework might eventually yield to some more comprehensive theory when phenomena like 3I revealed its limitations. The fear was not that science was wrong, but that it was always unfinished, always vulnerable to the next observation that would demand expansion or revision of fundamental principles. And so as 3I continued its silent journey toward the outer solar system, its tiny gravitational anomalies carried implications that stretched far beyond astronomical curiosity, serving as potential harbingers of a new physics that humanity was not yet equipped to understand. The object had become Einstein's shadow, a reminder that even the most beautiful theories were still human constructions, subject to revision when the universe revealed aspects of itself that had never been anticipated by their creators. If Einstein's equations provided the scaffolding for understanding 3I gravitational behavior, then the words of Stephen Hawking cast an ominous shadow over the implications of what such an object might represent for humanity's future in the cosmos. Hawking had spent much of his later career warning about the potential dangers of contact with extraterrestrial intelligence, arguing that humanity should be cautious about broadcasting its presence to the galaxy, and even more careful about how it responded to potential evidence of alien visitation. His concerns were rooted in the sobering lessons of terrestrial history, the repeated pattern of technological disparities leading to tragedy when advanced civilizations encountered less developed societies. The outcomes had rarely been favorable for the technologically inferior party, regardless of intentions or cultural values on either side. Within NASA's research divisions, these warnings resonated with particular force as the anomalies associated with 3I accumulated beyond what conventional astrophysics could easily explain. If the object represented technology rather than natural debris, if it was indeed some form of probe or artifact from an intelligence capable of interstellar engineering, then Hawking's cautions about the dangers of contact took on immediate relevance. The object's silence provided no comfort within this framework, for silence could be strategic rather than indicating absence of intelligence. A truly advanced civilization might have no interest in announcing its presence to less developed species, preferring observation to communication, surveillance to contact. The absence of radio signals from 3I might reflect not the lack of artificial origin, but rather the sophistication of whatever intelligence had created it. Why should alien technology operate according to human expectations about communication protocols or energy signatures? The fear that gnawed at NASA's researchers was not the dramatic scenario of invasion that dominated popular entertainment, but something more subtle and potentially more dangerous: the possibility that humanity was already under observation by intelligences whose capabilities and intentions remained utterly opaque. Even the discovery of long-dead artifacts would fundamentally alter the cosmic equation, proving that intelligence was not unique to Earth, while simultaneously demonstrating that technological civilizations could and did vanish from the galactic stage. Such knowledge would force humanity to confront its own mortality as a species, recognizing that intelligence might be a temporary phenomenon in cosmic evolution rather than a permanent feature of the universe. Hawking's warnings took on prophetic weight when viewed through the lens of 3I Atlas's mysterious properties, reminding researchers that the universe might already be occupied by forms of intelligence so advanced that their artifacts would be indistinguishable from natural phenomena. To encounter evidence of such intelligence, even in the form of ancient debris, would be to realize that humanity was not exploring an empty galaxy, but rather investigating a cosmic neighborhood that might already be thoroughly mapped and catalogued by minds whose perspectives and priorities remained unknowable. The emotional weight of this possibility was not lost on scientists who had devoted their careers to the search for extraterrestrial life, suddenly confronted with the prospect that such life might already have found them first. If 3I Atlas represented the visiting card of an intelligence capable of interstellar engineering, then humanity's role in the cosmic order was fundamentally different from what generations of researchers had imagined. We would be the observed rather than the observers, subjects of study rather than pioneers of exploration, perhaps even specimens in some vast galactic catalogue whose purposes and methods remained beyond human comprehension. Philosophically, Hawking's voice continued to resonate, because it reminded the scientific community that intelligence, whether terrestrial or extraterrestrial, operated according to principles of survival and resource competition that might transcend cultural and biological differences. An advanced civilization capable of launching objects across interstellar distances would represent a form of intelligence that had solved problems of energy, materials, and engineering that humanity could barely begin to imagine. Such capabilities would inevitably reflect evolutionary and technological pressures that might have produced forms of intelligence as alien to human understanding as human intelligence was to that of insects. To make contact with such intelligence, even indirectly through the study of its artifacts, would be to enter into a relationship whose terms would be entirely dictated by the more advanced party. And history suggested that such relationships rarely ended well for the less developed participant, regardless of the intentions or ethical frameworks operating on either side. Thus, in the sterile corridors of NASA facilities around the globe, Hawking's warnings served as a constant reminder that the discovery of 3I might represent not just a scientific breakthrough, but potentially the end of humanity's cosmic childhood. The object's silent passage through the solar system could be interpreted as either a sign of benign indifference or as evidence that humanity was already being evaluated according to criteria and standards that it could not comprehend. Either interpretation carried implications that stretched far beyond astronomy into realms of philosophy, politics, and species survival that no scientific institution was equipped to address adequately. And so the fear surrounding 3I Atlas became not merely fear of the unknown, but fear of knowledge itself, and the recognition that some discoveries might fundamentally alter humanity's place in the universe in ways that could never be undone. The echoes of Hawking's warnings served as a sobering reminder that the next phase of human cosmic evolution might not be determined by our own choices, but by the responses of intelligences whose existence we were only beginning to suspect. The fear that 3I Atlas inspired extended beyond its immediate properties and behavior into questions that touched the very foundations of planetary evolution and biological history, questions about the role that interstellar visitors might play in seeding or reshaping entire worlds across cosmic time. Could objects like this be more than mere messengers from distant stellar systems? Could they serve as active agents in the development of life itself, carrying between stars the biological or chemical components necessary for the emergence of complex ecosystems? The concept of panspermia, life spreading between worlds on fragments of rock and ice, had long occupied the margins of respectable biology, considered plausible but largely unverifiable given the technical limitations of current research methods. Microorganisms embedded deep within the crystalline structure of meteoritic material might indeed survive the radiation and cold of interstellar space, hibernating for millions of years before potentially seeding new worlds with the biochemical foundations of life. If 3I Atlas represented such a carrier, then its passage through our solar system was not merely astronomical but biological in significance, part of a vast galactic network of genetic exchange that connected distant worlds through the patient migration of life itself. The question that haunted astrobiologists was whether Earth's own biological history might have been shaped by similar visitors, whether the seeds of terrestrial life had originally arrived from another stellar system aboard objects indistinguishable from 3I ATLS. But darker possibilities shadowed these thoughts like storm clouds gathering on a distant horizon, for if interstellar visitors could bring life, they could just as easily bring death. High-velocity impacts from objects traveling at interstellar speeds would release energies far exceeding any terrestrial catastrophe in recorded history, capable of sterilizing continents or even rendering entire planets uninhabitable for complex life forms. The geological record preserved evidence of mass extinction events that had periodically reset the course of biological evolution, some clearly associated with asteroid or comet impacts, others remaining mysterious in their origins and mechanisms. Could some of these ancient catastrophes have been caused by visitors from other stellar systems, interstellar objects whose impacts had literally rewritten the history of life on Earth? In this interpretation, wanderers like 3I Atlas represented both creation and destruction, harbingers of biological innovation, and agents of evolutionary catastrophe, operating according to the random dynamics of galactic collision, rather than any intentional plan or purpose. NASA's planetary scientists considered these scenarios with the mixture of fascination and horror that accompanies contemplation of forces beyond human control or comprehension, recognizing that the implications extended far beyond the study of a single object. If life could indeed be transported between stellar systems, if biological evolution was shaped not only by local environmental factors, but also by genetic contributions from across the galaxy, then Earth's biosphere was part of a much larger and more complex system than anyone had previously imagined. But the corollary was equally unsettling. If extinction could be delivered from interstellar space with the same ease as life itself, then no world was safe from cosmic catastrophe, regardless of how carefully its inhabitants managed their local environment. The timescales involved in such processes dwarfed human history and even geological epochs, operating across millions or billions of years, according to rhythms that made individual species and civilizations seem like brief fluctuations in a much larger pattern. Yet the immediate presence of 3I Atlas in our solar system served as a reminder that these vast processes were not merely abstract theoretical possibilities, but ongoing cosmic dynamics that continued to operate in the present moment. Philosophically, the implications forced a fundamental reconsideration of Earth's place in the cosmic order, transforming our planet from an isolated experiment in biological evolution into a single node in a galactic network of life, death, and transformation. To observe 3I Atlas was potentially to witness one small component of this larger system in operation, a fragment of the machinery that had been shaping the development of life throughout the galaxy for billions of years. But whether that machinery operated according to random chance or some deeper pattern remained unknowable, hidden within the silent trajectory of an object that offered no clear answers to the fundamental questions it raised about the nature of life and death in an interconnected universe. The fear was not merely of collision or contamination, but of recognition that humanity existed within systems of cosmic evolution whose scales and purposes exceeded anything that terrestrial science had yet learned to comprehend. And in that recognition lay both humility and terror, the understanding that our species might be subject to forces and cycles that operated entirely beyond the reach of human influence or understanding. Among the more unsettling possibilities whispered in the corridors of NASA's theoretical physics divisions was a scenario that pushed the boundaries of speculation into realms that bordered on cosmic horror, the notion that 3i Atlas might represent a fragment of reality itself under threat. Deep within the mathematics of quantum field theory lurked the troubling concept of vacuum instability, the possibility that the universe itself might exist in a metastable state, balanced precariously above some lower energy configuration that would fundamentally alter the laws of physics. If such a collapse were ever triggered, if the quantum vacuum that underlies all of space and time were to suddenly transition to a more stable state, the consequences would extend far beyond biological or even astronomical catastrophe. The laws of physics themselves would change, atoms would unravel, chemistry would cease to function, and reality as humanity understood it would simply. How could an interstellar visitor like 3i Atlas possibly relate to such an ultimate scenario of cosmic destruction? The connection was speculative and terrifying in equal measure, rooted in the possibility that objects traveling between stellar systems might carry with them exotic forms of matter capable of triggering exactly such a vacuum collapse. If the object contained strange quarks, particles of matter stabilized under conditions that did not exist anywhere in our local cosmic environment, their presence in the solar system might represent a seed of instability that could propagate outward at the speed of light. The collapse would be both instantaneous and invisible, a wave of altered physics that would erase entire stellar systems without warning, leaving no time for escape or preparation. It was a fear so extreme that it bordered on the irrational, yet it was grounded in legitimate theoretical physics that could not be dismissed entirely regardless of how unlikely the scenario might be. NASA's physicists rarely discuss such possibilities in formal settings, recognizing that the speculative nature of the threat made it inappropriate for policy discussions or public communication. Yet the persistent anomalies exhibited by 3i Atlas, its resistance to classification within known categories of matter and motion, provided just enough uncertainty to allow such scenarios to take root in the darker corners of scientific imagination. For if the object could not be explained through conventional physics, if it indeed represented matter or phenomena that operated according to rules not yet understood by human science, then the range of possible risks it might pose expanded to include threats that transcended anything in terrestrial experience. The philosophical implications were staggering to contemplate, suggesting that individual civilizations might rise and fall, not due to local factors like resource depletion or environmental degradation, but due to random encounters with forms of matter capable of altering the fundamental structure of reality itself. In such a universe, intelligence would be forever vulnerable to accidents of cosmic scale, discoveries that seemed promising but carried hidden potential for universal catastrophe. The fear was not merely of 3i Atlas as a specific object, but of what it represented as a symbol of humanity's cosmic ignorance. The recognition that our species was experimenting with forces and phenomena whose ultimate consequences remained utterly unpredictable. Yet there was another dimension to the vacuum collapse scenario that offered a different kind of hope and terror, the possibility that such exotic matter might also represent the key to understanding reality at its most fundamental level. If 3i Atlas carried within its structure examples of physics that operated beyond the standard model, if it offered glimpses of quantum mechanical principles scaled up to macroscopic levels, then studying it might provide insights into the deepest questions of theoretical physics. The same exotic matter that posed existential risks might also offer unprecedented opportunities for scientific advancement, windows into the structure of space-time itself, that could revolutionize human understanding of the universe's basic operating principles. Danger and discovery were inseparable in such scenarios, twin aspects of encounters with phenomena that transcended the boundaries of current knowledge. Thus, 3i Atlas carried within its silent passage not only the potential for immediate scientific insights, but also the ultimate question of whether humanity was prepared to encounter realities that might be simultaneously enlightening and annihilating. The object served as a reminder that the universe operated according to principles so vast and complex that even the act of observation might carry risks that extended beyond anything in human experience or imagination. And in that possibility lay perhaps the deepest source of fear associated with interstellar visitors, not that they might bring immediate threats to Earth or its civilizations, but that they might force humanity to confront aspects of reality that were simply too dangerous to understand fully. As 3I Atlas continued its trajectory toward the outer reaches of the solar system, it carried with it questions that touched the very foundations of what it meant to be a curious species in a universe that might be fundamentally hostile to curiosity itself. Among the most profound speculative possibilities surrounding 3I Atlas was the notion that it might represent not merely a visitor from another stellar system, but a fragment from another universe entirely, a cosmic refugee that had somehow crossed the boundary between separate realities to arrive in our local space-time. The multiverse hypothesis had evolved from the realm of pure speculation into a legitimate area of theoretical physics research, suggesting that our observable cosmos might be merely one bubble in an infinite foam of universes, each operating according to its own physical laws and cosmological constants. If such parallel realities existed, if the boundaries between them were not absolutely impermeable, then objects might occasionally slip from one universe into another, carrying with them the signatures of alien physics that would appear anomalous when viewed through the lens of local natural law. 3I Atlas's persistent resistance to classification within familiar categories suddenly took on new meaning within this framework, its unusual behavior potentially reflecting not damage or technological modification, but fundamental differences in the physical constants that had governed its formation in some other cosmic domain. Perhaps its matter had been assembled under conditions where gravity operated more weakly, where electromagnetic forces followed different scaling relationships, where the speed of light itself differed from the value measured in our local space-time. Such an object would inevitably appear strange and inexplicable when evaluated according to the physics that operated in our universe, not because it was artificial or damaged, but because it was literally foreign in the most fundamental sense possible. NASA's theoretical physicists approached such ideas with even greater caution than they applied to conventional exotic matter scenarios, recognizing that multiverse theories remained largely beyond experimental verification despite their mathematical elegance. Yet the accumulated anomalies of 3I Atlas demanded explanation of some kind, and if conventional physics within our own universe proved inadequate, then perhaps the explanation lay in physics from elsewhere entirely. The implications of interuniversal visitors stretched far beyond scientific curiosity into realms of philosophy and cosmology that challenged the most basic assumptions about the nature of reality. If fragments could cross between parallel universes, if the boundaries of space-time were porous rather than absolute, then our cosmos was not the closed system that generations of scientists had assumed it to be. Instead, it would be part of a vast multiverse ecosystem, subject to immigration and emigration of matter and energy, according to principles that human science had not yet begun to investigate. But such possibilities also carried profound risks that made even exotic matter scenarios seem manageable by comparison. For if objects could cross from other universes into ours, what else might follow? What if the physical laws operating in some parallel reality were not merely different but actively hostile to the continued existence of matter as we understand it? A fragment from such a universe might serve as a seed of instability, gradually altering local space-time until the physics of our region began to resemble those of its origin, potentially rendering our entire cosmic neighborhood uninhabitable. The fear was not merely of contact with alien intelligence, but of contamination by alien reality itself, the gradual transformation of familiar physics into something that could not support the complex chemistry necessary for life as we know it. Yet the multiverse interpretation also offered a strange form of comfort, suggesting that intelligence and life might be far more common than anyone had imagined, if they could evolve independently in countless parallel realities. The silence of our local universe might reflect not cosmic solitude but cosmic isolation, our reality separated from potentially vibrant communities of intelligence by barriers that were normally impermeable. 3I Atlas, in this interpretation, became a kind of cosmic message in a bottle, a fragment of evidence that intelligence existed elsewhere in the infinite expanse of parallel realities, even if direct communication remained impossible across the boundaries of space-time. Philosophically, the multiverse scenario forced confrontation with questions that transcended traditional scientific methodology. If reality itself was layered and multiple rather than singular and absolute, then what did it mean to seek truth about the nature of existence? Which universe's physics represented the correct description of natural law? Or were all such descriptions merely local approximations to some deeper truth that operated across all possible realities? The object's passage through our solar system would then represent more than a scientific discovery. It would be an ontological revelation, proof that existence itself was far more complex and interconnected than any single universe could contain. And so the whispers of interuniversal origin joined the growing catalogue of explanations for 3I Atlas's anomalous properties, each more speculative than the last, yet each offering glimpses of possibilities that expanded the boundaries of human imagination beyond anything previously contemplated. Whether the visitor was natural debris, technological artifact, exotic matter, or interdimensional refugee, its presence had already succeeded in forcing humanity to consider questions about the nature of reality that stretched the very foundations of scientific understanding. The universe, or multiverse it seemed, was determined to remain stranger than any single theoretical framework could accommodate, and 3I Atlas served as a humble reminder that the cosmic order might be infinitely more complex than even the boldest human speculation had yet dared to imagine. The enigma of 3I Atlas also awakened connections to one of the most profound mysteries of modern cosmology, the accelerating expansion of the universe driven by the phenomenon that physicists had labeled dark energy for lack of a better term. For decades, astronomers had known that the cosmos was not merely expanding, but expanding at an ever-increasing rate, as though driven by some hidden force that permeated all of space and operated in opposition to the attractive pull of gravity. Dark energy represented perhaps the most significant gap in scientific understanding of the universe's basic architecture, a placeholder name for ignorance about the fundamental forces that would ultimately determine the fate of all matter and energy across cosmic time. Could the strange behavior of 3I Atlas somehow be connected to this cosmic mystery, its anomalous motion and properties, reflecting the influence of dark energy on scales much smaller than galaxies and galaxy clusters? The speculation emerged from careful consideration of the object's trajectory and the subtle forces that appeared to be influencing its motion in ways that conventional gravitational models could not fully explain. If dark energy was indeed a fundamental property of space-time itself, if it influenced the motion of all matter throughout the universe, then interstellar visitors might serve as natural test particles, carrying with them the accumulated effects of dark energy interactions across vast distances and cosmic times. The tiny deviations from purely gravitational motion that had been detected in 3I Atlas' orbit might represent the first direct measurement of dark energy effects on individual objects, signatures too subtle to detect in local solar system dynamics, but accumulated to measurable levels during million-year journeys between stars. In this interpretation, every interstellar visitor became an inadvertent probe, delivering data about cosmic acceleration and the structure of space-time that could not be obtained through any other means. But the implications of such a connection stretched far beyond academic interest in cosmological parameters, for dark energy was not a gentle force operating at comfortable distances from human experience. It was the dominant component of the universe's energy budget, the factor that would ultimately determine whether the cosmos would expand forever into cold emptiness or suffer some more dramatic fate as the acceleration continued to increase. If 3I Atlas carried within its motion the signatures of dark energy influence, then it was also carrying news about humanity's ultimate cosmic destiny written in the language of orbital mechanics. The fear was not merely academic, for current understanding of dark energy suggested that its influence would only increase with time, eventually overwhelming all other forces and tearing apart the fabric of space-time itself, in a scenario cosmologists grimly referred to as the Big Rip. In such a future, even atoms would be torn apart by the relentless acceleration of cosmic expansion, leaving behind a universe of isolated subatomic particles separated by ever-increasing distances in an eternal cold death. To discover that 3I Atlas was already being influenced by dark energy effects would be to receive direct confirmation that this ultimate cosmic catastrophe was not merely theoretical, but actively operating in the present moment. NASA's cosmologists discussed these possibilities with the mixture of excitement and dread that accompanies any encounter with phenomena that operate on scales beyond human control or comprehension. The technical challenges of detecting dark energy effects in the motion of individual objects were staggering, requiring precision measurements that pushed existing instrumentation to its absolute limits. Yet the potential scientific payoff was equally extraordinary: the possibility of studying dark energy through direct observation rather than statistical inference from distant galaxies and supernovas. If interstellar visitors could indeed serve as dark energy detectors, then humanity had been presented with an unprecedented opportunity to study the force that would ultimately determine the fate of everything in existence. But such knowledge came with its own burden of responsibility and fear, for to understand dark energy was to confront the finite nature of all cosmic structures, including the civilizations and intelligence that had evolved within them. Philosophically, the connection between 3I Atlas and dark energy served as a reminder that even the most exotic visitors were ultimately subject to the same cosmic forces that would eventually dissolve all complexity back into the primordial simplicity of empty space. The object's journey between stars was not merely a passage through space, but a voyage through time toward a future where even the galaxies themselves would be torn apart by the relentless acceleration of cosmic expansion. And in that recognition lay perhaps the deepest source of unease associated with the object's discovery, not fear of its immediate properties or potential origins, but awareness that it served as a messenger from a universe that was fundamentally impermanent, subject to forces that made all achievements temporary and all discoveries provisional. Thus, 3I Atlas became entangled with humanity's growing understanding of cosmic mortality, serving as both a scientific opportunity and an existential reminder that the universe itself was aging toward a destiny that no intelligence could prevent or escape. Through months of intensive study, NASA turned not only its most powerful telescopes toward 3I Atlas, but also activated its most sensitive radio astronomy facilities in a systematic search for any electromagnetic signals that might betray artificial origins. The Great Radio Observatory at Arecibo before its collapse, the Green Bank Telescope in West Virginia, and the Allen Telescope Array in California were all enlisted in the effort to listen for transmissions from the mysterious visitor. If the object were indeed some form of technology, if it possessed the capability for communication or data transmission, then surely it would emit detectable signals across some portion of the electromagnetic spectrum. The search protocols were exhaustive, scanning everything from low-frequency radio waves that could propagate across interstellar distances with minimal attenuation to high-frequency signals that might carry vast amounts of data in compressed bursts. Yet the outcome was silence so complete and profound that it became more unsettling than any signal might have been. At first, this electromagnetic silence seemed reassuring to those who preferred natural explanations for 3I Atlas's properties, a confirmation that they were observing an ordinary piece of cosmic debris rather than advanced technology. After all, rocks do not broadcast, ice does not transmit, and the absence of artificial signals suggested that whatever else the object might be, it was not an active communication device. But for researchers who had studied the history of SETI, the search for extraterrestrial intelligence, Silence was never a simple answer to questions about the presence of technology in space. It could indeed indicate the absence of artificial systems, but it could equally well represent deliberate concealment, technological sophistication beyond human recognition, or communication methods that operated outside the electromagnetic spectrum entirely. The precedent was sobering. Oumuamua had also maintained perfect radio silence during its passage through the solar system, offering no electromagnetic clues to resolve the debate about its nature that continued years after its discovery. If both objects were indeed examples of alien technology, then their silence might reflect a consistent policy of non-interference or observation without communication. Alternatively, it might simply indicate that human assumptions about technological signatures were fundamentally incorrect, based on terrestrial engineering principles that bore no resemblance to methods developed under alien conditions. For NASA's SETI researchers, the silence of 3I Atlas became a mirror reflecting humanity's limitations in recognizing intelligence that might operate according to entirely different principles than those governing human technology. Why should alien engineering emit radio waves detectable by Earth-based instruments? Why should technological artifacts announce themselves through electromagnetic signatures that human science had learned to recognize? The assumption that advanced technology would necessarily be noisy in radio frequencies reflected a fundamentally anthropocentric bias, the projection of human engineering solutions onto intelligences that might have evolved under completely different circumstances and constraints. Perhaps true technological sophistication lay precisely in the ability to operate without detection, to accomplish complex tasks while remaining indistinguishable from natural phenomena to less advanced observers. In this interpretation, the radio silence of 3I Atlas was not evidence against artificial origin, but potentially the strongest evidence in favor of it. The fear that emerged from this line of reasoning was philosophical rather than immediate. The recognition that humanity might be surrounded by evidence of intelligence so advanced that its very sophistication rendered it invisible to current detection methods. If 3I Atlas was indeed artificial, if it represented technology that had achieved perfect biomimicry or physical stealth, then the solar system might already be thoroughly explored and catalogued by intelligences whose presence remained undetectable. The silence became more ominous than any signal could have been, a reminder that in a universe populated by truly advanced civilizations, the absence of obvious technological signatures might be the most telling signature of all. Telescopes strained at every available wavelength, scouring the object for regular pulses, narrowband transmissions, or bursts of structured electromagnetic activity that might reveal hidden complexity beneath its apparently simple exterior. Nothing emerged from the cosmic static, no whisper of artificial intelligence, no hint of embedded communication systems, no trace of the radio fingerprints that human technology scattered so promiscuously across the electromagnetic spectrum. Yet for those who understood the deeper implications of Hawking's warnings about advanced civilizations, this silence carried its own message, the possibility that genuine technological sophistication might be defined not by what it revealed, but by what it concealed. The search for signals thus became less about detection than about philosophical reflection on the nature of intelligence itself, forcing humanity to confront the possibility that true wisdom might lie in remaining unnoticed, rather than announcing one's presence to the cosmos. If silence was unsettling in the radio spectrum, it proved equally frustrating when humanity turned its newest and most sophisticated optical instruments toward the mysterious visitor. The hope had rested on the transformative capabilities of the James Webb Space Telescope, its unprecedented infrared sensitivity capable of detecting thermal signatures invisible to previous generations of instruments, combined with the wide-field survey capabilities of the Vera C. Rubin Observatory, designed to catalogue the entire sky with systematic precision. These represented humanity's sharpest eyes ever turned toward the heavens. Yet even under the scrutiny of these technological marvels, 3I Atlas remained stubbornly enigmatic, refusing to resolve into the clarity that advanced instrumentation had promised. James Webb's golden mirrors captured infrared spectra of the object, but the data spoke in riddles rather than revelations. Thermal emissions were detected, but they followed no pattern that could be easily interpreted as either natural outgassing or artificial heat management. There were hints of complex carbon chemistry, suggestions of organic compounds that might be either biological in origin, the result of radiation processing of simpler materials over cosmic timescales. But the signatures remained frustratingly ambiguous, capable of supporting multiple interpretations without clearly favoring any single explanation. The object was simultaneously too complex to be a simple rock and too subtle to be obvious technology, existing in that liminal space where uncertainty breeds rather than resolves with additional observation. The Vera Rubin Observatory, still in its commissioning phase during 3I Atlas's passage, promised to revolutionize the detection of interstellar visitors through its ability to survey the entire sky repeatedly with unprecedented sensitivity. Where previous surveys had caught perhaps 3 or 4 such objects per decade, Rubin was expected to find dozens, possibly hundreds, providing the statistical sample necessary to determine whether 3I Atlas represented an anomaly or part of a larger pattern. But that promise lay in the future, and for the present visitor, the window of detailed observation was closing as it receded toward the outer solar system. Each night of lost observing time was irreplaceable, each failed attempt to resolve the object's true nature, another step toward permanent uncertainty. This reliance on increasingly sophisticated instruments carried its own burden of irony. Humanity had reached the point where individual telescopes could image galaxies billions of light-years away with exquisite detail, yet a single object within our own solar system continued to defy comprehensive analysis. The cosmic perspective was simultaneously humbling and terrifying. If Webb and Rubin could not settle the question of 3I Atlas's nature, what hope was there that future instruments would prove more successful? Perhaps the limitation was not technological but fundamental. Perhaps some mysteries were designed to remain mysterious regardless of the sophistication of the tools brought to bear upon them. In the halls of NASA, conversations grew more subdued as it became clear that even humanity's most advanced observational capabilities might be insufficient to resolve the deepest questions surrounding the visitor. The fear was not merely of missing important details, but of confronting the possibility that the universe might contain phenomena that actively resisted human attempts at understanding. If 3I Atlas was natural, but operated according to physical principles not yet incorporated into terrestrial science, then no amount of observational refinement would yield clarity until theoretical understanding advanced to match the complexity of cosmic reality. If it was artificial but designed by intelligences whose engineering philosophy emphasized concealment, then detection might require not better instruments but entirely different approaches to the recognition of technological signatures. And if it was something else entirely, something that transcended the categories of natural and artificial that formed the foundation of human classification, then perhaps no amount of technological advancement would ever be sufficient to decode its true nature. The limitations of even the most sophisticated instruments thus became symbols of deeper limitations in human understanding, reminders that the universe operated according to principles that consistently exceeded the boundaries of current knowledge. 3I Atlas continued its silent journey toward the outer reaches of the solar system, carrying with it questions that even the combined observational power of Webb and Rubin could not answer definitively. The object had become a mirror, reflecting not only the cosmos, but also the persistent gaps in human capability to comprehend what the cosmos might be trying to reveal. The fleeting passage of 3I Atlas brought with it a recurring frustration that had plagued astronomy since the first interstellar visitor was detected, the fundamental limitation that observation alone could never provide the detailed analysis that such objects demanded. Astronomy is inherently a passive science, capable of gathering light and analyzing electromagnetic radiation, but unable to touch, sample, or interact directly with the phenomena it studies. Yet 3I Atlas hurtled through the solar system at speeds that made interception by current technology essentially impossible, a cosmic tease that offered tantalizing glimpses before disappearing forever into the interstellar void. And so conversations within NASA began to shift from immediate observation toward long-term preparation, bold proposals for missions that could intercept not this visitor but the next one that appeared in Earth's cosmic neighborhood. Concept studies proliferated through the agency's planning divisions, engineering challenges that pushed the boundaries of current propulsion technology towards scenarios that had previously existed only in science fiction. Could a spacecraft be pre-positioned in the outer solar system, equipped with rapid response thrusters, capable of pivoting quickly to intercept objects whose trajectories could only be predicted days or weeks in advance? The technical requirements were staggering, demanding propulsion systems far beyond anything in humanity's current arsenal, guidance computers capable of calculating intercept trajectories in real time, and scientific instruments robust enough to function during high-speed encounters with unknown materials. Other proposals imagined launch-on-alert missions, spacecraft pre-built and stored in readiness, waiting for the detection of suitable targets before being deployed on intercept trajectories that would require months or years to complete. Such missions would demand international cooperation on scales never before achieved in space exploration, pooling resources and expertise from multiple agencies and nations in pursuit of objectives that transcended any single country's technological capabilities. The conversations also turned to more exotic propulsion concepts that might make true interstellar pursuit possible. Nuclear pulse drives, fusion ramjets, or even more speculative technologies like solar sails optimized for rapid acceleration. Each concept carried its own burden of technical challenge and political complexity, but also the promise of transforming humanity from passive observers of cosmic mysteries into active participants in their investigation. For NASA's mission planners, the pursuit of interstellar visitors represented both the ultimate expression of human curiosity and a practical necessity for species survival. If objects like 3I Atlas were indeed representatives of advanced technology, then direct study might be humanity's only chance to acquire knowledge that could prove crucial for long-term cosmic security. Even if they proved entirely natural, the ability to intercept and analyze interstellar materials would provide unprecedented insights into the formation and evolution of planetary systems beyond our own. But such capabilities lay years or decades in the future, dependent on technological developments that remained largely theoretical and political commitments that had not yet been made. For 3I Atlas itself, the window of opportunity was closing with each passing day, its trajectory carrying it beyond the reach of any conceivable pursuit mission using current technology. The object would join Oumuamua and Borisov in the catalogue of cosmic mysteries that had appeared briefly in human awareness before vanishing forever, leaving behind only questions, and the persistent sense that something crucial had been missed. The fear that haunted these discussions was not merely technical but existential, the recognition that humanity might be living through an era of cosmic contact while lacking the capabilities necessary to recognize or respond to that contact appropriately. Each missed opportunity to study an interstellar visitor was potentially a failure to acquire knowledge that could determine the future of human civilization, intelligence about cosmic threats, technological insights, or even evidence of life beyond Earth. And so the proposals for pursuit missions became more than engineering exercises. They represented humanity's attempt to transform itself from a passive observer of cosmic phenomena into an active participant in galactic exploration. The challenge was not merely to build faster spacecraft or more sophisticated instruments, but to develop the institutional framework and international cooperation necessary to respond quickly and effectively to opportunities that might appear without warning. 3I Atlas had taught a sobering lesson about the limitations of reactive science, but it had also inspired a vision of proactive exploration that might one day allow humanity to pursue its cosmic visitors, rather than simply watching them disappear into the darkness. Thus, even as the object itself receded beyond the reach of detailed observation, its passage had already begun to reshape human ambitions for space exploration in ways that might ultimately prove more significant than any immediate scientific discoveries about its nature or origin. Beneath the technical discussions and theoretical speculation, another question stirred within NASA's research community. With increasing urgency, 3I Atlas continued its journey toward the outer solar system. What if the object represented not merely a scientific curiosity to be studied and catalogued, but a mirror reflecting humanity's own nature and choices back at the species that had discovered it? The philosophical implications of interstellar visitors extended far beyond questions of origin and composition, into realms of moral responsibility and cosmic ethics that no scientific institution was equipped to address adequately. If 3I Atlas was indeed artificial, if it represented the handiwork of intelligence from beyond our solar system, then its discovery forced confrontation with questions about how humanity should respond to evidence of non-terrestrial technology. The visitor had maintained perfect silence throughout its passage, offering no obvious signs of active communication or interest in establishing contact with Earth. Should that silence be respected, or was there an obligation to attempt communication despite the apparent lack of invitation? If the object was a relic of extinct civilization, a technological fossil drifting through space long after its creators had vanished, then what responsibilities did humanity bear toward such artifacts? The precedents from terrestrial archaeology offered some guidance, but the scale and implications of cosmic archaeology transcended anything in human experience. Even if entirely natural, 3I Atlas forced recognition that Earth existed within a galactic community of worlds, connected by the patient migration of matter and perhaps life itself across interstellar distances. Such recognition carried its own burden of responsibility, the understanding that humanity's actions might have consequences that extended far beyond the boundaries of our own solar system. For NASA as an institution, these philosophical questions posed challenges that were perhaps more difficult than any technical puzzle associated with the object's physical properties. The agency had been founded to explore space and advance scientific knowledge, but it had never been designed to grapple with the ethical implications of contact with non-terrestrial intelligence. Yet, the discovery of 3I Atlas, whether artificial or natural, had already begun to reshape public perception of humanity's place in the cosmic order in ways that demanded thoughtful response rather than technical analysis alone. The responsibility was not merely to interpret the data correctly, but to serve as guardians of perspective, helping society understand the implications of cosmic discoveries without either sensationalizing them or dismissing their significance. In this sense, 3I Atlas had become more than an astronomical object requiring classification. It had evolved into a test of human wisdom, challenging our species to respond appropriately to phenomena that transcended all previous experience. The fear was not only of misunderstanding the visitor's nature, but of revealing through that response the limitations of human judgment when confronted with truly cosmic questions. How humanity reacted to 3I Atlas would inevitably serve as a precedent for how our species might handle future encounters with interstellar visitors, establishing patterns of behavior that could prove crucial when more obviously significant contact scenarios eventually emerged. The object's silent passage through the solar system was thus simultaneously an opportunity and a responsibility, a chance to demonstrate that humanity was capable of responding to cosmic mysteries with the combination of curiosity and humility that such encounters demanded. But it was also a reminder that intelligence, whether terrestrial or otherwise, carried with it obligations that extended beyond mere survival or technological advancement into realms of cosmic citizenship that no single species could navigate entirely alone. NASA's scientists found themselves in the uncomfortable position of being not merely observers of cosmic phenomena, but participants in what might prove to be humanity's first tentative steps toward mature membership in a galactic community whose rules and expectations remained utterly unknown. The responsibility was both thrilling and terrifying, offering the possibility of transforming human civilization, while simultaneously risking everything that made that civilization worth preserving. And so, as 3i Atlas continued its silent journey away from Earth, it carried with it not only the mysteries of its own origin and nature, but also questions about the kind of species humanity wished to become when faced with evidence that the universe was far stranger and more populated than previous generations had dared to imagine. Through months of intensive analysis, NASA marshaled every available technological resource in an attempt to extract additional information from the enigmatic visitor before it passed beyond the reach of detailed observation. Powerful computational tools were brought to bear on the problem, supercomputers analyzing thousands of orbital measurements to refine trajectory calculations with unprecedented precision. Sophisticated models simulated every conceivable combination of natural forces that might account for the object's anomalous behavior, testing scenarios involving outgassing, radiation pressure, magnetic field interactions, and gravitational perturbations from previously undetected solar system bodies. The Hubble Space Telescope contributed its legendary imaging capabilities, attempting to resolve surface features or structural details that might provide clues to the object's internal composition and history. Ground-based observatories coordinated their efforts to maximize coverage, ensuring that 3i Atlas remained under constant surveillance as it faded toward the detection limits of even the most sensitive instruments. Spectroscopic analysis was pushed to its technical limits, extracting every possible photon of reflected sunlight and analyzing its wavelength distribution for chemical signatures that might reveal the object's true nature. Each measurement was subjected to multiple independent analyses, cross-checked against theoretical predictions, and compared with data from previous interstellar visitors to identify patterns or anomalies that might have been missed in earlier studies. The effort represented one of the most intensive astronomical campaigns ever mounted to study a single object, a collaboration between institutions and individuals that transcended national boundaries and academic rivalries in pursuit of answers to questions that affected all of humanity. Yet, despite this unprecedented mobilization of scientific resources, 3i Atlas continued to resist definitive classification. Every analysis seemed to raise as many new questions as it answered. Every measurement refined the mystery without resolving it. The object remained suspended between categories, too strange to be entirely natural yet too subtle to be obviously artificial, too complex to be simple debris, yet too ambiguous to be clearly technological. It was as though the universe had crafted a perfect enigma, designed specifically to frustrate human attempts at understanding while tantalizingly suggesting possibilities that remained forever just beyond the reach of confirmation. For the researchers involved in this intensive study, the experience was both humbling and inspiring, a reminder that even the most sophisticated scientific methods had limits when confronted with phenomena that operated at the boundaries of current knowledge. The data accumulated like pieces of a cosmic jigsaw puzzle, each measurement adding detail to the overall picture without revealing the complete image that would allow confident interpretation of what they were observing. But perhaps that was the point. Perhaps some discoveries were meant to challenge rather than satisfy human curiosity, forcing the expansion of conceptual frameworks rather than merely filling in details within existing paradigms. The ongoing efforts to understand 3i Atlas thus became more than a scientific investigation. They evolved into a meditation on the nature of knowledge itself and the relationship between human intelligence and cosmic reality. Each negative result, each inconclusive measurement, each failed attempt to extract definitive answers served as a reminder that the universe operated according to principles that consistently exceeded the boundaries of terrestrial understanding. And yet the effort itself was valuable, not only for the technical knowledge gained through pushing observational methods to their limits, but also for the philosophical insights that emerged from confronting the limitations of those methods. In straining to understand 3i Atlas, Humanity was also learning to understand itself, discovering both the power and the limitations of scientific methodology when applied to phenomena that might be fundamentally alien in nature. The visitor had become a cosmic teacher, offering lessons not only about the nature of interstellar space, but also about the nature of inquiry itself. Its resistance to easy categorization was perhaps its most important characteristic, a reminder that reality might be more complex, more layered, and more mysterious than any theoretical framework could adequately capture. Thus, as 3i Atlas continued its journey toward the outer solar system, it carried with it not only the secrets of its own origin and composition, but also the accumulated weight of human attempts to decode those secrets. The object had become a mirror, reflecting back at its observers their own assumptions, limitations, and aspirations in the quest to understand their place in a universe that seemed determined to remain at least partially unknowable. And in that reflection lay perhaps the deepest lesson of all, that the act of questioning might be more important than the answers obtained, and that some mysteries were meant to inspire continued exploration rather than provide comfortable closure. The story of 3i Atlas, though it resisted the kind of definitive conclusion that scientific methodology typically demanded, carried humanity to a threshold that was simultaneously terrifying and magnificent. The recognition that our universe was far stranger and more complex than any previous generation had dared to imagine. In its silent passage through the solar system, the object had forced a confrontation with questions that transcended mere astronomy, questions about the nature of reality, the possibility of intelligence beyond Earth, and humanity's place in a cosmic order that might be populated by phenomena and entities whose existence challenged every comfortable assumption about life in the galaxy. For NASA and its global partners, the fear had never been solely about the possibility of collision or immediate physical threat, though those concerns remained valid and troubling. The deeper unease had emerged from recognition 3i Atlas represented something qualitatively different from any previous astronomical discovery. Whether natural fragment or technological artifact, whether ancient debris or active probe, whether exotic matter or interdimensional refugee, the visitor had succeeded in demonstrating that the solar system was not the isolated sanctuary that human imagination had long assumed it to be. Our cosmic neighborhood was porous, permeable to influences and visitors whose origins, intentions, and implications remained utterly mysterious despite months of intensive study. The boundaries that had once seemed to separate Earth from the rest of the galaxy had proven to be illusory, psychological constructs rather than physical barriers, offering no protection from forces and phenomena that operated according to rules humanity had not yet learned to recognize. The philosophical questions raised by 3i Atlas's passage would persist long after the object itself had faded beyond the reach of telescopic observation, continuing to challenge assumptions about the nature of intelligence, the possibility of contact, and the ultimate destiny of technological civilizations in a universe that might already be thoroughly explored and catalogued by minds whose existence remained invisible to human detection. For the scientists who had tracked the visitor's trajectory and analyzed its anomalous properties, the experience had been transformative in ways that extended far beyond the accumulation of technical knowledge. They had joined a lineage that stretched back through Galileo's first telescopic observations, through Herschel's discovery of nebulae, through Einstein's revolutionary insights about the nature of space-time, each generation of researchers adding threads to a tapestry of understanding that never quite revealed its complete pattern. 3i Atlas had become one such thread, enigmatic and unfinished, but essential to the larger picture that humanity was slowly assembling through patient observation and careful analysis of phenomena that consistently exceeded the boundaries of current knowledge. The visitor had not provided answers in any conventional sense, but it had succeeded in sharpening the questions that would guide future exploration and theoretical development. What did it mean to be alone or not alone in a universe where silence might be strategic rather than indicative of absence? How should humanity respond to evidence of phenomena that might be artificial but remained unverifiable as technological in origin? What responsibilities did a young technological civilization bear when confronted with possible artifacts from intelligences whose capabilities and motivations remained utterly alien? These were not questions that could be answered through spectroscopic analysis or orbital mechanics. They required wisdom that transcended technical expertise, drawing upon philosophy, ethics, and intuitive understanding of humanity's place in a cosmic order that seemed determined to remain at least partially mysterious. And so, as the narrative of Three-Eye Atlas drew toward its inevitable close, as the object itself receded into the darkness between stars where it would resume its patient journey through the galactic void, the fear that had initially motivated its study transformed into something more complex and ultimately more valuable. Fear of the unknown had evolved into respect for mystery, recognition that some aspects of the universe were meant to inspire continued questioning rather than provide comfortable answers. The visitor had taught humanity to pay attention, to watch the skies with new appreciation for the possibility that the next point of light detected by telescopic surveys might carry implications that extended far beyond astronomical curiosity. NASA's scientists had learned to listen with enhanced sensitivity, to interpret silence not as absence, but as potential strategy, to recognize that the most significant discoveries might arrive cloaked in ambiguity rather than announced with obvious clarity. The agency's fear had matured into vigilance, the understanding that humanity stood at a threshold where the next cosmic visitor might provide the definitive answers that Three-Eye Atlas had withheld, or might pose even more profound questions about the nature of reality and intelligence in a universe that seemed infinite in both scale and strangeness. Now, as this chronicle reaches its natural conclusion, as the object designated Three-Eye Atlas continues its silent trajectory toward destinations unknown, the story itself begins to slow, settling into the kind of cosmic patience that measures time not in human heartbeats but in the orbital periods of distant worlds. Imagine the galaxy itself breathing slowly, its spiral arms rotating with stately grace across eons that dwarf the entire history of human civilization. The interstellar objects that drift between stellar systems move like thoughts across the cosmic mind, carrying information and perhaps intention from regions of space that no human eye will ever directly observe. Three-Eye Atlas has rejoined, that ancient current, resuming its place among countless other wanderers whose journeys began in stellar nurseries now long extinct, and will continue until the universe itself grows too old and cold to sustain the complex chemistry necessary for rocks and ice to maintain their structural integrity. Against such scales of time and distance, human concerns about the object's nature and origin begin to seem both precious and temporary. The fear that once motivated frantic observation campaigns transforms into something gentler, a recognition that mystery itself might be one of the universe's most valuable gifts to any species curious enough to notice it. The telescopes that tracked Three-Eye Atlas now turn their attention toward other regions of the sky, scanning for the next faint point of light that might carry similar questions across the cosmic darkness. The equations that described its anomalous motion wait patiently on computer drives and research databases, ready to be compared with future visitors whose behavior might finally provide the context necessary for understanding. Even the debates about artificial versus natural origin have settled into a comfortable suspension, neither resolved nor abandoned, but held in the kind of intellectual equilibrium that allows continued exploration without demanding premature closure. The scientists who devoted months of their careers to studying the visitor have returned to other projects, but they carry with them a changed perspective on what it means to explore a universe that might already be thoroughly inhabited by phenomena whose existence exceeds human ability to recognize or understand. You might picture the Earth itself as it peers from interstellar distances, a pale blue dot orbiting an ordinary star in the outer regions of an unremarkable galaxy, home to a species that has recently learned to detect cosmic visitors but not yet developed the wisdom to interpret what those visitors might represent. From such a perspective, humanity's encounter with Three-Eye Atlas becomes just one small chapter in a much larger story that encompasses the rise and fall of countless civilizations across cosmic time, each species eventually learning to notice the wanderers that drift through their cosmic neighborhoods, each grappling with the same fundamental questions about solitude and contact, in a universe that seems designed to remain perpetually mysterious. The object continues its journey through space that is simultaneously empty and full, empty of the kind of obvious activity that human senses can detect, yet potentially full of intelligence and intention operating according to principles that remain invisible to current scientific methodology. Perhaps 3I Atlas was indeed a natural fragment, a piece of cosmic debris, whose strange behavior resulted from exotic but entirely natural processes that human science has not yet learned to recognize. Perhaps it was technological, an artifact from intelligences whose engineering philosophy emphasized concealment and whose presence in our solar system represented the kind of routine survey activity that advanced civilizations might conduct throughout the galaxy. Or perhaps it was something else entirely, a phenomenon that transcended the categories of natural and artificial that form the foundation of human understanding, operating according to principles so alien that no amount of scientific advancement would ever render them comprehensible to minds evolved under terrestrial conditions. The uncertainty no longer feels threatening, but rather appropriate to a universe that seems determined to remain larger and stranger than any single species' ability to comprehend. And in that acceptance of mystery lies perhaps the greatest gift that 3I Atlas brought to human civilization, the reminder that curiosity is more valuable than certainty, that questions can be more profound than answers, and that the act of wondering might be the highest expression of intelligence in a cosmos that consistently exceeds the boundaries of imagination. So let the visitor continue its silent journey, carrying with it the accumulated weight of human observation and speculation, but also the graceful acceptance that some stories are meant to remain unfinished. The universe is patient in ways that dwarf human understanding, and perhaps that patience is one of its most beautiful characteristics. Sweet dreams, fellow travelers, and may your own journeys through space and time be filled with the kind of wonder that makes even unanswered questions feel like gifts.